Uh, Before going to start this batch, which is ICND 1, right? Let's start with the introduction and let's find out what is your requirement for this course. Okay. So let's start with you. Just tell me your name and your expectations from this course.
Yeah, my name is Christopher. Just hoping to get a better understanding of networking so I can help out my colleagues here. I'm currently just a help desk level 1 engineer.
Okay.
I'm hoping to expand my knowledge with networking so I can, better assist my colleagues at the company.
Okay, cool. My name is Rakesh Kumar. I have total 10 years of experience in IT training. I'm the master trainer for Cisco routing and switching and data center. Apart from that, I'm taking care of the checkpoint technology. Okay. Currently, I'm associated with Quick Start. Okay. Now, as a certification, I have CCNA, CCNP, CCIE written certifications in routing and switching. In data center, I have CCNA and CCNP data center. So this is my small technical background. So we are here for next 3 days, right?
Yes.
Okay. Okay. What is the current time in your country?
It's currently 8:39 a.m. over here.
8:39. Okay. So at any time you can take tea or coffee break and just let me know about your lunch timing so that I will proceed the courseware according to that.
Okay.
So right now, if you have 8:30, so at what time you will take lunch break?
1 p.m. So in about 4 or 5 hours.
Okay, cool.
So this is a accelerated ICMD 1 course.
Right. I'm just going to explain that thing. Okay. Are you able to see my screen?
I am.
Okay. In CCNA, we had 2 books, ICND 1 and ICND 2. So right now we are studying this courseware.
Okay.
So ICND 1 is Inter-Network Connecting Network Devices. So basically in this course, we will get the basic overview of network.
Okay.
There will be lots of labs, but the labs will be basics. Okay. This ICND 2 will be the core of the network. Okay, so the most of the lab will be in this courseware. First, let me know, have you received any email from cisco.com regarding the lab access?
Yes.
Okay, so you will get a lab access. Okay, once you log in there, you will get approximate 57 labs, right?
Okay.
So in that 57 lab, that lab is not particular for ICND 1. Actually, in that lab, they combine ICND 1 and ICND 2 labs, both.
Okay.
Okay, so we will focus only on those labs which are into the ICND 1. Okay, if time left, then we can do some important labs which is into the ICND 2. That will be not an issue, but if time left. Okay, now if you go for the exam perspective, ICND 1 exam is 100, 105.
Okay.
If you are going for exam ICND 1, this is the exam code. If you pass this certification, your certification will be CCENT, Cisco Certified Entry Level Network Technician. Now, this exam code is 200, 105. If you pass both the examinations, then you will be CCNA certified. For the CCNA certification, there is a combo examination also, 200, 125. It's a combo examination which include ICND 1 and ICND 2 both. You will also receive a courseware email, right?
Okay.
You have to register with yourself to the cisco.com, and there will be a access code in the mail. Let me show you that thing. Not this one. This kind of mail will be there in your
Okay.
so you have to firstly register yourself into the cisco.com. Through that, you will get a username and password. You have to create that thing. After that, click on this. You will log in into the cisco.com and you will get a access code in your mail. You have to redeem that access code.
Okay.
So once you redeem that, you will get a courseware online. So you can read that PDF only online. You cannot download, you cannot print. Okay. There will be no limit for that thing. That will be added in your account and that will be forever.
Okay.
So first point is computer network. What is network? So basically network is a interconnectivity of multiple devices, right? Which shared a common sharing medium. For example, you have laptop, you have desktop or servers, you have printers, you have switches, you have routers, which is connected with the internet. Like this way. PC server. This is my router and ISP. So network is a interconnectivity of the devices which shared a common shared medium and they can communicate with each other. If you talk about the network, if you go into the software, so there will be like work group and domain. If you go with the physical network, in that case, we have, if I talk about types of network, we have LAN, we have MAN, and WAN. If you define the network based on the operating system, in that case, we have domain and work group. So that is not our part. We will discuss the physical type of network, which is LAN, MAN, and WAN.
Are you going to be sending us copies of these of your presentation?
Yeah, I will share that thing. That's not an issue. At the end of the day, I will share that thing.
Okay, cool. I'm also trying to take notes as we go along.
Okay, not an issue. Hopefully, after the end of the training, you will get this recording of this training also.
Cool.
So that will be helpful for you. Now. So we have a home office, branch office, network, mobile users, and the main office. So if we connect all these networks, right, then it will become a, you can say, network.
Okay.
So how they will connect, it depends on the technology. So there are lots of technology through which we can connect the multiple sites, multiple users, multiple branches. For example, if you have all the branches into the same city, then you can take ISDN lines. You can take a end-to-end dedicated line through the ISP and you can connect that thing. You have frame relay, MPLS. There are lots of type of tunnels are there. GRE tunnel is there. DMVPN tunnel is there. So it depends on your requirement, how you want to connect the branches. If you talk about the physical component of a network, so physical component of a network, there is a firewall. Let's start with the PC. In the PC, there will be mandatory part NIC card, NIC, which is known as LAN card. Now switch. Switch is used to connect multiple network devices. For example, like computers, printers, servers, all those things. If you want to connect locally all the devices in a room, in a campus, then all the devices will be connected through the switch. Router. If you want to communicate inside to outside or from one network to another network, then you need a router. So router main task is to perform the routing. For example, let us assume we have these 4 computers. If I assign IP address here, let's say 10.0.0.2, 10.0.0.3, So let's say PC A, B, C, and D. Can PC A communicate with the PC B? Yes, Christopher. Can communicate
Hello.
PC A to PC B?
PCA to PC, can they communicate, you asked?
Yeah. Okay. Can I communicate PC A to PC C?
No.
No. Why? Because they are into the same subnet and they belongs to into same subnet. If you want to communicate these two different subnets, then you need a router. If you have router, then you can communicate IP subnet. You have to perform routing over there, and after routing, they can communicate. Switch is just a interconnectivity device. Clear this thing? Firewall. Now, what is the use of firewall? Firewall is used to filter the traffic. So if you don't want to use, let's say there are certain URL which you don't want to allow in your internal network. So you can filter those URL on the firewall. So firewall will protect your network from outside attack. Then we have access point. If you want to connect all the devices through wireless, through wireless. So it's like a switch which will connect all the wireless client. There will be one more device, WLC, which is wireless LAN controller. Wireless LAN controller. So for example, you have these access point, and these are my computers which are connected through wireless. Now, If you want to manage this access point, you have to connect with the access point and you can manage. For example, if you want to set any SSID, anything, you have to connect locally on the access point and you can connect. But if you want centralized administration, so there will be a device which is known as WLC. So you can connect your access point with WLC. You have to register your access point through the WLC, and after that you can manage all these access points through this single device.
Okay.
It's like a centralized controller in wireless. Okay. So now characteristic of the network: topology, speed, cost, security, availability, scalability, and reliability. So we'll discuss all these parameters. So first, let's discuss about type of LAN. Sorry, LAN. So LAN is local area network. Networking at a small geographical place. In a building, in a room, so for example, you have these 4 computers. You can connect like this. So that will be a LAN. So if you are connecting multiple computers in a room, in a building, in a campus, that will be known as a LAN. Right?
Okay.
MAN. Metropolitan area network. So let's assume to connect 2 or more LAN within a city.
What was the acronym? You said Metropolitan
Area network.
Area Network. Thank you.
So let's assume we have these 2 branches, LAN 1, LAN 2, which is approximate 60 kilometers apart from each other. So please tell me what are the possible solutions to connect these 2 branches.
You said you need a MAN, right? A Metropolitan Area Network.
Yes. If I want to connect these branches which are 60 kilometers apart, how can I connect? Can I connect through the wireless?
No.
We cannot do, because in every 10 meter we have to put a access point and it will increase the cost, plus there will be no security, right? So wireless is not the feasible solution. Can I put end-to-end dedicated line, dedicated link?
No.
See, we can put,
Okay.
there is a option, there is a concept, lease line. Okay, we can connect through single fiber cable, which is the lease line. But what is the issue in that? The issue is it's a point-to-point connectivity. If you have multiple branches in the same city, then you have to purchase these lease line through the ISP, and the cost is very high. So if you have multiple branches or number of branches, you need the number of lease line according to the number of branch, and it will increase your cost. Again, it's a point-to-point connectivity. That's why we are not using this thing. But it will be the best solution if you want a dedicated bandwidth, and the cost doesn't matter in that case. Now, the best solution is you go with the ISP. This link will be the physical link. From here to here, physical link. Okay. So these two links are managed by the ISP, service provider, because you are paying for that thing. So you have to tell to the ISP, you want to connect these two branches, right? And the ISP will ask, okay, how you want to connect? You want to connect with the layer 2 link, or you want to connect with the layer 3 link? If you are going with the layer 2 link, so again, there are certain options. For example, you want to go with the ATM technology, you want to go with the VPLS technology, you want to go with the frame relay technology. So he will give you the options. So based on that, he will give the price, and you can connect your branches. So in this case, from here to here, the connectivity is managed by the ISP. So
Okay.
if this connectivity is up, this link will be up, and you
Okay.
can communicate the network. Again, here, if you have the same subnet, for example, like 10, here is also 10, you can directly communicate. If you have 10, here is 20, then you need a router between them.
Okay.
WAN. Okay, Christopher, please tell me, are you comfortable with this writing, or should I go with directly presentation?
No, it's fine.
Okay. WAN. WAN is to connect multiple branches or multiple sites, or you can say multiple LAN across the world. So the connectivity will be same. Again, you will connect with the ISP.
Okay.
Here I'm using switch, right? It can be a router, it can be a firewall, depending on the network design. Okay.
Okay.
Next is topology. Now, what is topology? Physical network devices arrangement in a regular and arranged manner. Okay.
Okay.
Now, topology is physical arrangement of the network and the devices in a regular and arranged manner. Types. So we have bus topology, we have ring topology, we have star, hybrid, and mesh. So these are the network topology. So right now in the network, you will see only the star and hybrid. So 99% you will get star and hybrid topology.
Okay.
So what is the bus topology? In the bus topology, all the devices are connected with a backbone cable. Like this way.
You said it's connected with what kind of cable?
Backbone cable, like coaxial cable. Coaxial cable. Right now, this cable is used in cable network, dish network. Okay. Now, this cable is used in small pieces, like this way. Now, this is the backbone cable through which all the devices are connected. In this topology, there is an issue. The issue is now speed. It is just providing 10 Mbps speed. Right now, we have devices which support 40 gig speed. Sorry, 400 gig speed, not 40. 400 gig speed. Right? And this 10 Mbps is like very less speed right now. Second, so first problem is speed, which is 10 Mbps. Second is max PC, 10. You can connect maximum 10 number of PC. And yes, in the bus topology. And in this topology, there will be a T-type connector, like this. So one end of this connector will connect to the PC, and these two ends connect with the cable. Clear this thing?
Yes.
Now, on the PC, the connector will be BNC, British Naval Connector. Right now, in the PC, we have RJ45 connector, right?
Yeah.
Before that, we have BNC connector, through which we can connect this coaxial cable. At the end of this cable, there will be a terminator. This terminator is used to stop the signal inside this cable only. Right?
Yes.
So now, if you want to communicate 1, 2, and 3, if you want to communicate PC1 to PC3, and there is a problem here, you cannot communicate.
Okay.
Now, and the administrator fault tolerance is not that much easy, right?
Wait, why can't you communicate?
If there is an issue in the network, for the administrator, fault tolerance is not easy, right? He has to check each and every point.
Okay.
Clear this thing? So this is the issue in the bus topology. Any question here?
No.
Next topology is ring. In ring topology, all the computers are connected with a backbone cable in a closed loop, like this way.
Okay.
If you want to communicate 1 to 5, so first thing, the data will not travel like this way. No. Data will always travel in a unidirectional, like this way.
Okay.
And issue with same speed, 10 Mbps. Okay.
And PCs as well.
Yes. The difference is only one. Here we don't require any terminator because this is a closed loop. Okay.
Okay.
Star. So right now we are using this topology in the network. Now what is the star topology? In the star topology, all the devices are connected with a backbone device. It can be a hub. It can be a switch. So all the devices are connected like this way. If any PC goes down, there will be no effect on the network. But if the central device goes down, the entire network will be down.
Okay.
Here, speed depend on the device. If this switch is supporting 100 Mbps, 1 gig, 10 gig, so speed of the network will be according to the intermediate device and what kind of NIC card you have placed in the device, in
Okay.
your PC. Now, next, hybrid topology. Now, hybrid topology is the intermixing of two or more than two topologies. For example, switch 1, switch 2. So this is the star. This is also star, right?
Okay. Yeah.
If I connect these two switches like this way also, so it will be a bus topology. So now you can say this is a hybrid topology.
Okay.
Intermixing of two or more than two topologies. It is not mandatory star and bus. It can be any topology. And the last is mesh. In mesh topology, all computers are connected with each other with multiple physical link. For example, if you have these 4 computers, So I have these 4 computers which are connected with the multiple physical link. So this type of topology is known as mesh topology. In mesh topology, one best benefit will be redundancy. If your any link goes down, no issue, you have another link, your connectivity will be not destroyed.
Okay.
But this mesh topology is not recommended, because just to connect these 4 computers, how many cables you are using? 1, 2, 3, 4, 5, 6. And based on the number of connectivity, you have to place the number of NIC card also, right? So just to connect 4 devices, your network will be complex and it will increase your cost. The best way, you put a switch between them and you can connect all the devices through the switch. Clear this thing? Bus topology, ring topology, star topology, and mesh topology. Okay. Now here they are telling physical versus logical topology. So physical topology means how we are connecting to the devices, and logical topology means once you connect the physical topology, then how my data will move, right? For example, there are PC A, B, and C, and they want to access this server, right? So if this PC A is accessing this server, so one connectivity is this way, you can connect through switch and switch to the server. But here it is going through the router, because maybe this server is having in different IP subnet. So if this is 10, this is 20, directly they cannot communicate. So firstly the request will go to the router will perform the routing process, and after that your request will forward it to the server.
Okay.
So physical and logical topology. The logical topology is how your data will travel.
Okay.
So they are showing like how the devices are connected with each other. Applications. Batch application, for example, like FTP, TFTP, inventory update. Now, what is FTP? FTP is file transfer protocol. If you want to access or if you want to upload your data on a centralized system, so you can use FTP protocol. So you have to configure this FTP protocol. You have to configure the FTP service on the PC, and then you are able to access this protocol. There is a protocol TFTP, Tribal File Transfer Protocol. This TFTP protocol is used to take the backup of your switches, your router, your firewall. Okay, if you want to take backup of those images which are present on the router, switch, and the firewall, you can use this protocol. So this TFTP is basically a software. You have to install that software into the PC, and that PC will behave as a TFTP server. And after that, you can save the configuration, you can save the images there into the TFTP. I will show you this lab, and we will discuss like how you have to perform the backup and restoration of the devices. Clear this thing?
Yes.
Okay. Understanding host-to-host communication layer. Hold on. So host-to-host communication. Have you heard about OSI reference model?
I have not.
So currently you are dealing with the operating system in day-to-day activity.
Okay.
We have two models in the data network. One is the OSI reference model and another model is TCP/IP. Let's assume we have two computers, A and B. If you are sending any data A to B, the actual movement of the traffic of the data is through the TCP/IP.
Okay.
Now, so what is the use of this OSI reference model? This OSI reference model is used to describe how my data is processing into the network. So this is for how data process into network, and TCP/IP actual data move through TCP/IP model, right?
Yes.
This model is designed or developed through ISO, International Standardization for Organization, and this model defined or designed by DoD, Department of Defense. So firstly, we'll discuss about the OSI reference model, and then we'll discuss about the TCP/IP model.
Okay.
My speed is okay, or
It's fine. Yeah.
OSI is Open System Interconnect. So this is just a reference model, or you can say a study model. We just describe how the data is processing into the network.
Okay.
It contains 7 layers. Application, presentation, session, transport, network, data link, and the physical. These are the 7 layers. If someone asks what is the layer 1, layer 2, layer 3, it always start from the bottom. So layer 1 is physical, 2, 3, 4, 5, 6, and 7. Right?
Yes.
And sometime in the some books also it is written like, or it is described through the application layer. Firstly, they are explaining the application layer. The reason is it depends how you are defining the data processing. Either you are a sender or you are a receiver. So if you are receiver, then you will start from the physical layer. If you are a sender, then you will start from the application layer.
Okay.
Now, let's start with the application layer. Application layer. So application layer is responsible for creating and receiving data. So if you are a sender, then you will create the data. If you are a receiver, then you will receive the data.
Okay.
User always interact with application layer. Okay. Now, if I talk about the protocol which are working here, then we have Telnet, SSH, HTTP. So if you want to access any device, then we have Telnet, SSH, HTTP. So these are all application layer protocol.
Okay.
Next is presentation layer. So presentation layer responsible for how data represent in front of user. How data will be represent in front of user means data format adds on this layer. For example, if I write abc.txt, what kind of file is this?
Text file.
It is a text file. So how you identify that thing? Through this, right?
Mm-hmm.
So this is the format of the data. So with the help of extension, I can identify, okay, what kind of data is that? So it can be a .exe, it can be .mp3, it can be txt, doc, any extension, right?
Yes.
Next layer is session layer. Session layer is responsible for creating and terminating session. Data communication mode work here. So data communication mode means simplex, half duplex, full duplex. Any idea about simplex?
No.
So simplex means data travel from source to the destination, but from the destination you will not receive any acknowledgement. Clear this point?
Yes.
For example, you are changing the temperature of the AC. So when you press the button, the data travels source to the destination, but destination is not giving you any acknowledgement, right?
Yes.
Half duplex. What do you mean by half duplex? At the same time, only one process will work, either sending of the data or receiving of the data.
Okay.
Any example of that?
No.
Okay, okay.
Okay.
Full duplex, at the same time, both the process will work. For example, mobile phone. Right?
Yes.
Any confusion in any terminology? Okay, if I combine the working of all these three layers, So we have application, presentation, and session. So we can say this application create the raw material or raw data.
Okay.
Here we add format. And here we are telling about the session. Session means in which format the data will travel.
Okay.
If you combine the working of all these three layers, then you can say a complete formatted data is ready.
Okay.
Next layer is transport layer. Transport layer is responsible for end-to-end logical connectivity. TCP and UDP protocol work here. Port number work here. Data segmentation. Data sequencing. And acknowledgement work here. Right?
Yes.
What is the data segmentation now? Any idea?
No.
Let us assume PCA, PCB. PCA want to send 10 MB data to B. Okay, so you can say it's a single data. Right? So just tell me, if I send this 10 MB file to anyone, so this 10 MB file will go in a single packet, or this data will divide into small packets.
Okay.
So whenever you forward this data, this big data will divide automatically into small pieces. And in these small pieces, it will travel to the destination. So this process is known as segmentation. Segmentation of the data. We are not doing anything. This process will be done by the operating system automatically. Okay. Have you heard about this word MTU? Maximum transmission unit. Every port is having a predefined amount of data which it can accept from any link. So normally on every port, the MTU size is 1500 byte. So that means a device can receive only this much amount of data in a single packet. Right? If the size is more than this, then the data will be discarded. In some condition, we can allow the bigger data also. So that thing is known as jumbo frame. So you have to enable that feature on the PC, on the devices also. Then only your port will able to receive that big data. Clear this thing?
Okay.
Sequencing means when your data is segmented, then every segment will receive a sequence number. Right? So this is known as sequencing. Acknowledgement. When you are sending file, or let's say a simple command. Normally you are using this thing. Let's say ping 10.0.0. Let's say 2. After that, you are getting 3 acknowledgement. Remember, reply from, request timeout, and destination host and reachable, right?
Yes.
These are the 3 options. So what are these? These are the basically acknowledgements.
Right.
Are you able to communicate with the destination or not? Okay. What is this port number? Any idea?
No.
If you are using this thing, let's say HTTP google.com, right? So this
Right.
google.com is my server anywhere into the world. What is this HTTP? HTTP is a protocol, a browser protocol, right?
Yes.
This HTTP work on port number 80. Every protocol is having a predefined port number. Every protocol. We can customize also. For example, like HTTP port number 80, HTTPS port number 443, FTP port number 20 and 21, SSH port number 22, Telnet 23, SMTP 25, right? Every protocol is having a predefined port number. Plus, if you want to manipulate that thing, if you want to change the predefined port number, you can do that part.
Okay.
According to your requirement. Next is network layer. Now, network layer is responsible for best route selection. IP protocol work here. IP address work here. Routing and security work here.
Okay.
Clear this thing. Okay. We miss a small point in transport layer. Let me write that thing. Transport layer. It's a very important point regarding the exam. Transport layer is also responsible for error checking and error correction. Now, what do you mean by this error checking and error correction? Let's say you are sending any data from PC A to PC B. Now, that is a big data, and that data is segmented now. So, I'm transferring first, then second, third, fourth, fifth, like this way. Let's say if any segment is missed due to any condition, then through the PCB, I will get a response. Okay, this part is missed. So please send me this data again. So that request will go to the PCA, and that PCA will send again that data. So this is known as error correction and error checking. Clear this thing?
Yes.
Network layer is responsible for the best route selection. For example, you are accessing google.com or any website that is in any location. It can be in US, it can be anywhere, right? So when your data reach to the service provider, On the service provider, there are n number of routes to reach the Google. So it will identify which is the best route for you. So it will forward your traffic or your request on that particular route, and you are able to get response from that server.
Okay.
So this task is done by the network layer, and on the network layer, router work. So router work here on the network layer.
Okay.
Next option is data link. Data link layer. Responsible for handling MAC address. Or it provide logical connectivity.
Okay.
Logical connectivity between network and physical layer. Actually, this layer is divided into two sub layers. One is known as MAC and LLC. MAC layer is used to handle this MAC address for this task, and this LLC is used for this task. Logical link control.
Okay.
Error checking work here.
So it also works in this layer as well?
Yes.
Okay.
But the difference is error correction only works on the transport layer, not here. If this layer identify there is the data is corrupted or some sequence is missed, then this layer will simply drop that request.
Okay.
Right?
Yes.
Switch work here. And the last one is physical layer. It provides end-to-end physical connectivity. Right? Let's say PC A is sending any data to PC B. So what will happen? Application, presentation, and session layer, these three layers will create the data.
Okay.
Okay, let's assume it's a big data. When this data reach to the transport layer, this data will be divided into segments.
Okay.
When this data reach to the network layer, this segment will convert into the packet. When this data reach to the data link layer, this packet will convert into the frame. And here everything will be converted into the bits and bytes. Okay. Let me explain this thing in this way also. This is your data. When it reach here, so it will divide into small pieces. So this piece is known as segment. What is packet now? Clear this thing? Collection of segment is known as a packet.
Okay.
So let us assume 10.0.0.1 and here the IP is 10.0.0.2. So as we discussed, on network layer IP protocol work. So IP protocol work and IP address work here. So that means on this packet, in this packet, there is a information of IP address. What is the source and what is the destination IP address? Clear this point?
Yes, I am.
When it reach to the data link layer, this is known as frame. And when it reach to the physical layer, everything will be converted into 0. So if you want to understand this frame, let's assume you are sending any letter to your relative or anyone. So there will be two things in the address on this letter. Whatever you are written, that is your data, right? After that, you are putting the address on that. So let's say home, street, like this way. So it can be the same address will be present in another city, right? House number, street number, it can be, but there is a zip code, right?
Yes.
So through the zip code, we can identify, no, okay, this address belongs to this locality. So here, MAC address works. So MAC address is like your zip code. Fixed address, MAC address.
Okay.
And it's your address. Clear this thing?
Yes.
Any confusion on this point?
No.
Whatever properties we discussed till now in this topic, OSI reference model, if you are giving the CCNA exam, there will be 3 questions from this section.
Okay.
Okay. So make sure you have remember all these points, and the questions are very easy. Okay. For example, like on which layer there will be data, like error checking occurs, error correction occurs, like this way.
Okay. I still have to register for the exam, correct?
Right.
Okay. So then I have some time so I can study all this over before I take it.
Yeah. I will give you all the things, right? You can practice your exam also. Okay. I will provide the complete content. Now, there can be, sorry?
It's a lot of information. So.
Yes. So there will be a question, what is the PDU? PDU. PDU is protocol data unit. Protocol data unit. So protocol data unit means what will be the conversion of the data on that particular layer. So if I ask what will be the PDU of application presentation and session, the PDU is data. Transport layer PDU is segment, network packet, and here is frame. Clear?
Yes.
So this OSI reference model is just for the study purpose. Our data is not traveling according to this model. This model is just designed to define how my data is processing into the network. That's it. My data actually traveling through the TCP/IP model. TCP/IP model. So this model is known as a practical model. It consists of 4 layers: application, host to host layer, inter-network layer, and last one is network interface layer. In some books, it is also a transport layer. Okay. So application layer. Application layer, again, this layer is responsible for creating and receiving the data, right? Host to host layer is just used to provide the end-to-end logical connectivity. Network layer will provide you the best route selection, and network interface layer will convert your data into bits and bytes, and it is responsible for the physical connectivity.
Okay.
So if you see through this model, I cannot explain the complete process, how my data is converted into the segment, packet, frame, right? So just to explain that process, they develop a OSI reference model, but my actual data is flowing through TCP/IP model. Clear this thing?
Yes.
Okay, let's take a 5-minute break and then we'll continue, right?
Sure. Can we do 10 minutes? I need to use the bathroom as well.
Sure, not an issue. 10 minutes.
Okay. Thank you.
Okay, bye. Yes, Christopher, are you there?
Hello, Rakesh.
Yes, are you there?
I'm here.
Okay, cool. So we discuss about OSI reference model and the TCP/IP model.
Okay.
Are you able to see my screen?
Yes.
Okay. So we discuss all these 7 layers.
Mm-hmm.
So here they are just mapping like with the OSI reference model and the TCP/IP model.
Okay.
Now, encapsulation and de-encapsulation. What do you mean by encapsulation in general? Any idea? Encapsulation?
No.
We have a capsule in medicine, right?
Mm-hmm.
What that outer cover is doing?
The outer layer?
Sorry?
You said what is it doing?
Yes. The drug is inside that outer
Yeah, it
cover,
keeps
right?
it contained in the capsule, yeah.
Right. So what is the working of this outer cover? That is that is not a medicine, right? It is just
No.
protector.
Yes.
Right. So encapsulation is the same thing.
Okay.
Whenever your data is traveling on any link, the link can be a Ethernet, can be a serial link, can be a virtual link, can be a tunnel, right? So whenever your data travel on any link, then the particular link encapsulation will be automatically added on that data.
Okay.
Okay. So encapsulation means wrapping of your data on the source end, and when the data reach to the destination, that destination doesn't require that extra information, which is my encapsulation. So it will remove that outer cover and the data will be reached to the destination.
Okay.
So that process is known as de-encapsulation. Clear this part?
Yes.
So encapsulation means adding the data, and de-encapsulation means removing that data.
Okay.
So let me explain this thing with a basic simple example. PCA. So that PCA is having application, presentation, so let us assume this A is my sender.
Okay.
And here is a PCB. All the 7 layers will be here also. Okay. If A is a sender, so he will create a data on application layer. So let's assume this is my data. This data will go to the presentation layer. This presentation layer will not accept this data until and unless it is not verified. So just for verification, application layer add a header. In that header, there is only one information. Yes, the data is corrected. Okay.
Okay.
So just for easy simplification and understanding, I'm writing AH. AH means application layer header, and as it is my data.
Okay.
So same process will happen when the data travel presentation through the session layer. Session layer is also require authentication. The data is verified or not. So just for verification, it add PH presentation layer header and whatever information he has, AH and the data. Right? So in the same way, every layer need to verify the data. So they will add, you can say, headers on the data link layer. What you will get, headers plus the data. Right?
Right.
When this data reach to the physical layer, everything will be converted into the 0 and 1 form, which is the binary. This physical connectivity, provide the physical connectivity, physical link. The same information reach to this, let's say here. But in this information, there is a extra information which is header, which is not a meaningful information, because you can, let's say this data is my 10 MB data. If it reach on the receiver end, then it will become, let's say, 15 MB. So that 5 MB data is extra, which the destination doesn't require, right? So this process, this header process, this one is basically what? Encapsulation.
Encapsulate. Okay.
So this process is just protecting your data, but it will put extra overhead on my data. So how it will be removed? So what will be the de-encapsulation process? So when this data again combine, it will be headers plus my data. So when this data reach data link to network layer, it will add one authentication token, which is known as, let's say, DT, data link tailor. Okay, so here headers will be added and here tailor will be added. Okay, there will be a DH, data link header, right? So they will neutralize themselves. Or you can say this header information will be swapped here and the rest of the data will be processed on the upper layer. So
Okay.
same way, DH, NH, TH. So on application layer, you will it will receive only the data.
Okay.
So this process, removing of these headers, is
Encapsulate.
basically de-encapsulation. Right?
Yes.
So de-encapsulation is done through the tailor and encapsulation is done through the headers. Right?
Yes.
So here they're explaining the same thing. Okay. Introduction to the LAN. This part we already discussed. Local area network, networking at a small geographical place, maybe in a campus, maybe in a building. Remember one thing, whenever anyone talk about the LAN, there will be layer 1 and layer 2 device only. Layer 1, layer 2. Layer 1 is my PC, NIC card, servers. Layer 2 device, switch or hub. Hub is a
Okay.
basically layer 1 device, right? And layer 2,
Yes.
switch and bridge. So component of the LAN, host, PC or servers. Interconnection can be NIC card, your LAN card, and network media may be your cable. Network devices can be your switches, can be your routers. Protocol, it can be Ethernet protocol, it can be IP protocol, it can be R protocol, it can be a DHCP.
Okay.
What is DHCP? In your company, are you getting IP address automatically or you are putting statically?
Get them automatically.
Automatically. So that IP address automatically assigned by the DHCP server. Okay. IP, you are defining the IP protocol, right? IP addressing. Ethernet is you are connecting with the RJ45 connectivity, UTP cable, right? So that is your Ethernet. And what is ARP? Address Resolution Protocol.
What is that?
ARP is used to resolve MAC address into the IP address.
Okay.
Okay. So LAN component, PC, access point. There is a wireless LAN controller which is used to manage the multiple access point, network printer, file server, right? Okay. Need of the switches. Why you require the switch? Okay. We'll discuss that switch maybe after 15 minutes. Before that, we'll discuss about the network devices. Okay. Do you know the cable type? Cables, all kind of cable?
Briefly, yeah.
Okay. So let's first complete the cable. After cable, we'll discuss about the network devices. Then we'll reach to the switch. Actually, in this book, the topics are not in a systematic way. So immediately they will start the switch, immediately they will start the router, and after that they will discuss the IP address. Okay.
Okay.
So I will go in a systematic way. Firstly, I will just discuss about the basic part. Then I will discuss the IP. Then I will do the switching and routing. Right.
Okay.
So maybe if you see the book, the chapters like contents are here and there. So don't be confused because we are here for the 3 days. So we have to utilize the time so that we will able to cover all the topics.
Understood.
Cable. So what is cable? Cable is basically a media, transport media, you can say. Transmission media. Through which our data is traveling. So types of cable. Coaxial, twisted pair, fiber optic. Coaxial cable is basically two type, 10^2, 10^5. Twisted pair cable is divided into two category. One is UTP and one is STP. Further, through these cable, we have to create a straight cable, cross cable, and the third one is rollover cable.
Okay.
Fiber optic cable are basically two type. One is single mode cable and multi-mode. Right?
Yeah.
This 10^2 is known as thin net cable, and this is known as thick net cable.
Okay.
So now discuss one by one all these kind of cables. So firstly, I'm going to discuss coaxial cable. So this cable is used as backbone cable in bus and ring topology.
Okay.
So it is having two type, 10^2 and 10^5. So 10^2 means 10 Mbps speed, baseband signal till 200 meter. It is approximate 200 meter. Actual value is 185 meter. So remember this point. That will be a question in your exam.
Okay.
In CCNA. Okay. After 150 or 200 meter, let's say this is a 10^2 cable, right? So if this 200 meter over, then After that, let's say there is a device A here and there is a device B here. And if you want to connect these two devices through this cable, so what you have to do, you have to add another device which is known as repeater. Then only you can extend this cable.
Okay.
Okay, it's a repeater, or sometime it is also called amplifier. (10^5) means same way, 10 Mbps speed, baseband signal till 500 meter. So after 500 meter, if your destination is on after 500 meter, 700 meter, like that, then again you have to connect with the repeater, and then only you can connect the destination.
Okay.
Clear? Right now we are not using this cable into the networking. This thing is only used right now into the cable network, TV network. Next type of cable is
Twisted pair.
twisted pair. Have you seen this cable?
I have not.
Have you seen LAN cable?
Yes.
LAN cable is a twisted pair cable.
Oh, okay.
Okay. Now, this twisted pair cable is having, if you cut that cable, you will get four pairs. So let us assume this is your cable. Okay. So in this cable, the major color will be blue. Orange, brown, and green. And one cable will be in the combination like green, white, orange, white, like this way. Clear this thing? So
Yes.
here you will get 4 pair, total 8 cables. Have you seen any cable which is having only 2 pair?
I have not.
Okay. See, in this 8 cables, only 4 cables are used for the network or data transmission. So 1, 2, 3, and 6. These 4 cables. 1 and 2 is for TX, 3 and 6 for RX. TX transmission, RX for receiving. Right?
Yes.
So what will be the use of rest 4 cable? Why we are putting there? Have you seen access point?
Yes, we have here.
How you are giving power supply to the access point?
Not sure.
IP phone, Cisco IP phone.
Hello?
Yes. Have you seen Cisco IP phones?
Yes.
Are you giving any power supply to the Cisco IP phone?
Yes.
How?
Ethernet?
Ethernet. So this is the answer. Rest of 4 cable used as a PoE, power over Ethernet. Means
Okay.
to provide the power supply to those devices which is not having direct power supply. For example, like your access point, your Cisco IP phone. Clear now?
Yes.
Now, here is one more question. In this, the name is twisted pair. Means the 2 cables are twisted with each other, right?
Mm-hmm.
If I have to put 8 cable in this cable, right, in this outer cover, why I am twisting? What extra benefit I am getting through the twist? Is there benefit, or like we are simply twisting just to reduce the size of the cable?
That's what I would think, just to reduce the size or have more of the cable.
You know, are you a science student?
No.
Okay. Sorry, sir. See, in like physics, there is a rule. Let me explain that thing. Let's say if your current is flowing in this direction, here current means our data, right? Our data is traveling in the form of the signals, and that signal is basically my current, right?
Yes.
So if my data is traveling straight, so what will happen? In the perpendicular direction, the magnetic field generate. So this is my data, which is going like this way. This magnetic field try to attract my data, and at certain time, certain interval, my data will be out of my cable. If I'm sending any radio frequency, if that radio frequency is goes out of the cable, so what will happen? My signals will be not, like picture quality, voice quality will be not that much good, right?
Yeah. Yeah.
So why it happen? Due to this magnetic field. So when we are twisting that cable, and the certain point where the cable cross each other, the magnetic field will be 0. Okay, so just to reduce this magnetic field, we are twisting the cable. Clear this thing. Otherwise, there will be magnetic field, and that magnetic field will attract my data, and my data will go outside the cable, and there will be loss of the data.
Okay. I didn't know that.
Yeah. So normally, whatever networking cable we require, we are directly purchasing from the market. But let's say if you have to make the cable, then you will go to the market and you will purchase either UTP cable or STP cable.
Okay.
UTP unshielded twisted pair, STP shielded twisted pair. So if you cut the cable, that LAN cable, you will get firstly that outer cover. Inside that you will get 4 pairs, right? If you are getting directly 4 pairs, that is a UTP cable. Okay. Outer cover and then cable. STP is basically, firstly you will get this outer cover. Inside that outer cover, you will get aluminum foil. And inside that you will get the cables. So STP is more stronger than your UTP, but the property wise UTP and STP are the same thing.
Okay.
Now these are the base cable. So whenever we will go to the market, we will purchase either straight STP or UTP. With the help of STP and UTP, we will make three kind of cable, either straight, cross, or rollover.
Okay.
So now, what is the use of straight cable? Straight cable use to connect different devices. Remember this point, different devices. For example, PC to switch, router to switch, right?
Yes.
Cross cable for same devices. For example, PC to PC, switch to switch, router to router, right?
Yes.
Rollover cable used to access network device.
Okay.
Through rollover cable, you cannot forward any data. You cannot forward. This cable is only used for accessing the network. For example, if you want to configure switch, if you want to configure router, if you want to configure firewall, first thing you have to access that device. So this rollover cable is here just used to access that device. Clear this thing. Right now, this rollover cable we have to make, okay? But when we are making this cable, we need a additional connector, which is AUI, attachment unit interface. So just for saving the cost, we are directly purchasing a cable from the market, and that cable is known as console cable. So that console cable is exactly same cable which is like rollover cable, right? Clear this thing?
Yes.
So let me show you all these cables. So console cable will be look like this. So this RJ45 AND will connect to the device, okay? And this
Okay.
AND will connect to your PC or your laptop.
Okay.
Now, straight cable. Okay, understand this picture basically. See, when you cut the cable, every cable is having two ends, right? So understand, this is one end, another is another end. So if you crimp the cable, if you make that cable, if both the side is color coding is same, like one is green white, another one is green, if the color coding is same on both the end, that cable is straight cable. Cross cable is having this combination. This combination is 1 2 3 6. Now what do you mean by 1 2 3 6? Whatever cable is on first number, on another it will be on third number. 2 that will be on sixth, 3 that will be on first, and the sixth that will be on second. So
Okay.
this combination if you make, then the cable will become the cross cable. Straight
Okay.
cable is used to connect the different type of devices. Cross cable is used to connect the same kind of devices.
Okay. Could you show me a picture of a rollover?
Rollover. I'm not sure the rollover cable will be here. Rollover cable. If you make opposite color coding, for example, like here they are showing this is the connector 1, this is the connector number 2. So whatever color coding is on first connector 1, 2, 3, like till 8. On another connector that will be opposite color coding. So for example, here first one is white brown. So that white brown is going on 8.
Oh, okay.
Second one is orange. Orange is 7th. So whatever color coding is on first connector, there will be opposite color coding on connector number 2.
I see.
Fiber optic. So in fiber optic, this cable is used to send data at high speed. High speed means here my data will travel with the speed of light.
Okay.
So this is basically coming under two model. One is the single mode. Single mode is for long distances. Long distances means if your source and destination is, let's say, 50 kilometer, 60 kilometer, like this, that much of distance. And multi-mode used to connect two or more switches or more devices in short distance. Let's say in your data center you had 2 core switches and you want to connect those 2 switches, then you have to use this multi-mode cable.
Okay.
So these are the type of cable.
Okay.
Next we have network devices. So under this network devices, there are lots of devices, let's say access point, firewall, WLC. But in this courseware, we have to discuss only about hub, switch, and router. Okay, so I'm going to explain one by one all the properties of hub, switch, and router.
Okay.
Again, hub is not in the network, right? So no one company is using hub right now. There are lots of limitations. What are the limitations we are discussing right now? Hub. First, it's a layer 1 device. It is a central connectivity device. It creates a single broadcast domain and a single collision domain. I will discuss this point later. What is the broadcast domain and collision domain?
Okay.
It divides the bandwidth. It works on half duplex. It doesn't have memory. It can't understand IP and MAC address. Okay, so how it works, let's say this is my hub, and on this hub these are the PC.
Okay.
1, 2, 3, 4. I want to send data here to here. So let's say I ping 10.0.0.4. So what will happen? The data will receive through the hub, right?
Okay.
This hub is not having any memory, so it doesn't know how I have to forward this data. So what will happen? This data will be forwarded to all the links, right? So when the PC2 received this packet, it will identify, okay, this is not for me, so it will drop. PC3, it is not for me, drop, and it will give reply. And this process will happen every time because it is not having any memory. So every time it will flood the traffic.
Okay.
This is the working of hub. Any confusion?
No.
Cool. Next one is switch. Switch is a layer 2 device. It work on MAC address. Or you can say it can understand the MAC address. It will forward the packet or it will forward the frame based on the MAC address.
Okay.
It create a MAC table. So whenever a switch receive any data, it will note down what is the source MAC and what is the destination MAC. And based on that, it will forward the information.
Okay.
It will not share the bandwidth. It work on full duplex. Create a single broadcast domain and and multiple collision domain.
Okay.
Router. So router is a layer 3 device. It understand IP address. Okay. Used to find out best path. Work on full duplex. Okay. And it divides the broadcast domain. Any confusion till now?
No.
All good?
Yes.
Okay. Just let me know, have you received this lab access detail? How to access the lab?
Through Cisco, right?
Yes, Cisco.
Yeah, I received the email. I already registered.
Okay. So let's do 1 or 2 labs so that we will familiar with the labs also. Okay.
Okay.
And then we'll continue the theory part. So today we have to complete the complete IP addressing, subnetting, supernetting, all those stuff. And we'll start with the basic thing. So tomorrow we have complete like whatever concept we will do, because today is the first day. So in the first day we have to just interact with the theory, and we have to interact how we have to perform the lab.
Okay.
Clear? Okay. So do one thing, try to open your lab. Just open that thing, don't start any lab.
Okay. I'm opening it right now. So it's interconnecting Cisco networking devices, accelerated lab guide. Is that the one?
No, 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 not that one.
Okay. Where can I find the lab?
Hold on. I will let me. Are you able to see my screen?
Yes.
Have you received this mail? Cisco learning, all this thing.
Let me check. No, it doesn't look like I received that one.
Okay. Have you received a link in the chat? Open that link.
Okay, I just opened it.
It is asking for the username.
Yes. You want me to log in?
This is the username.
That's the username?
Yes, that is the username.
Okay.
This one will be the password. Clear this thing.
Yes. Yeah, just let me log in.
So submit that thing.
Okay, it's asking me if I want to accept.
Accept that thing. And
Okay.
after that, you will reach here. Are you on the same page?
It's asking for contact and instructor details.
Okay, hold on. share your screen?
Sure. Okay, are you able to see that?
Yes. So
Okay.
enter your email address, whatever email address you shared with the quick start.
Okay.
Your first name, last name. Okay, there is an option skip assigning instructor. Yes, choose this one and submit. Yes, submit.
Okay.
Okay, so this is your lab. So
Okay.
understand first thing, this lab is not for ICND1. This lab is for the CCNA, right?
Okay.
So in this ICND1 and ICND2, both the labs are there. So there is no need to do all the lab, but you have the credential, right? Whatever username and password I shared with you, that is only for you.
Okay.
So if you want to do all these labs, you can do. That is no restriction. But what is the restriction here? Restriction is here, this time summary.
Okay.
So you have 7,200 minutes. So whenever you start the lab, this timer will start automatically.
Okay.
Whenever you are doing the lab, make sure there will be like, if you start the lab, you close that lab. Otherwise your timer will start and will run continue.
Okay.
And your time will expire very soon. So there is two conditions. Either you have 7,200 minutes and you have 3 months. So if you are not using this lab within 3 months, after 3 months, that lab will be automatically destroyed.
Okay.
Clear this thing. So first thing is the discovery number 1. So click on that, start lab.
Okay. Begin lab.
Begin lab. So this is the topology. So you just minimize your. Now, firstly, click on introduction. So they will tell you like, okay, the devices are like this way. You have to do whatever you want to do, right? So just close this thing. Now click on job ad. Second tab. So here they will tell you like what is the name, what is the IP address. These configuration is pre-configured there on the devices.
Okay.
Okay, down. Just down the scroll bar. Okay. So this information you have to verify actually. Clear? Close this
Okay.
thing. Third one is click on procedure tab. So in this procedure, they will be telling you the task 1, task 2, task 3, and all the solution will be there. You have to follow this step and you have to verify all these activity.
Okay.
Clear? For example,
Yes.
there is a switch 2. Go up, little bit up. Switch 2. So there will be a switch 2, right? In this picture, in this topology. You click on that switch 2.
Right here.
Yeah, click here. Okay, open. Yes, simply click open. Open. Okay, nothing is happening. So go back, previous page, back. No,
Click
back
that.
option. Yeah, from here. Leave this thing. Go back once again. Okay. In the downloads, there is a Cisco terminal installer, right?
In
Here.
download?
Yeah, in downloads here. Above. There. Below the time summary. This one.
Oh, below time summary.
Yeah, here. Little bit down.
Oh, okay, I see. Right here, Cisco
Yeah.
terminal installed.
Yes. Install that thing. Download and install. Okay. Now again, click on the Start Lab. Now click on the switch number 2. Open SSH terminal. Okay. Previously, it is not coming because we haven't installed any terminal. So
Okay.
normally we require putty or some other party software. For example, like in Windows, we have hyperterminal. Another software we have putty. Another software we have Terraterm. So these are the software to access the console of the device.
Okay.
Click enter. Okay. So now you are on the switch number 2.
Okay.
So note down this thing. So whenever you will access any device, so you will get this SW2. This is the name which they assign to that particular device. Okay. We can change it. I will show you all the commands. So firstly, if you are first time accessing any device, so you will get this greater than sign.
Okay.
This thing is known as enable mode. Enable mode or user mode. Clear this thing?
Yes.
How many commands will be working here? Simply type question mark here. So all these commands you can run in this terminal, but these commands are for all the environment. For example, routing and switching, security, and all those stuff, right? It's not limited to the ICND1 or CCNA.
Mm-hmm.
Clear? Press the space
Yes.
bar. All these commands, okay? Space bar once again. Now, so this mode is known as enable mode or user mode.
Okay. This, right? With the greater than sign, you said?
Right.
Okay.
So here normally you can run enable, disable, or all these commands, whatever you are showing here. Next mode, if you enter into the next mode, you have to type here enable. Enter. So your mode change. This mode is known as privilege mode.
Okay.
In this privilege mode, you can run all the show and verification commands, and you can test the connectivity, for example, like ping and all those stuff. Clear?
Okay.
These modes will be same for the router, switches, firewall, everywhere in the Cisco.
Okay.
Enable mode, privilege mode. Clear? So
Yes.
type again question mark here. Okay. So you are getting all these commands. Clear? Space bar.
Yes. Mm-hmm.
Space bar once again. Space bar. So if you see in this mode, you are getting more command than your enable mode, right?
Yes.
Okay. Let's verify some basic command. So first thing is show version. Please note down these commands side by side on any notepad. Show version.
Show.
Space version.
Can you spell that for me, please?
Version. VERSION. Enter. So this command will tell you what is the current iOS version. For example, like in PC, we have Windows 7, XP, Vista, Windows 10, right? So
Yes.
same way, every device is having a operating system. So what is the version of the particular iOS? So here, if you see, maximize this window. Enter once again. enter. See here, the version is, after this show version command in the second line, your version is 15.1. Getting this thing?
Mhm.
So right now the current iOS versions, latest version are 15.x till 15.6 is available. So this is your 15.1. Okay.
Okay.
Okay. Enter or space bar. Okay. Next command, show flash. Show flash is not working. This command is not working because this device is a virtual device. Okay, if you have the real switch, that command will work. Okay, not an issue. Show IP interface brief. Show space IP space interface space brief.
What was the last one?
Brief. Enter. So now you can see here this command will display if you assign any IP address to any interface or any VLAN. Clear this thing? So last VLAN one you assign the IP address. We will do all the things like we have to configure the IP addressing, all those stuff. We will do all the things. Okay. Okay. Next command, show interface status. Okay. So this command will display like how many interfaces you have.
Okay.
Next, show history. So what this history command is showing you, last 10 commands it will show, right?
Okay.
If you want to increase this history, you can increase that thing also. Okay. If you want, like by default, it will remember maximum 20 command. It depends on the iOS version, right? But if you want to like remember more command, there is a command you can run that command. For example, like terminal space history, terminal space history space size. No. Terminal space history space size. After that, let's say 50 space 50. Enter. Terminal spelling mistake.
Oh.
Okay. Now this device will remember last 50 commands. But to increase the history size, it's not recommended.
Okay.
Why? Because router task is not to memorize the command. Because if you are putting history size 50, so some amount of memory and the CPU will be reserved just to memorize the command. Clear this thing?
I see.
Now, next is configuration mode. So now type here config T. Configure space terminal. Configure space terminal. In short, you can type config T also. Enter. So you can see your mode is changed right now. This mode is known as global configuration mode. If you want to do anything globally on the device, for example, like putting the password, putting the host name, so you have to do all the things through the global configuration mode.
Okay.
Right? So for example, this switch is having a name SW2. Right? If you want to change this name, then there is a command host name. Type host name space any name, whatever name you want to do. Any name, whatever name you want to give to this switch. Enter. Clear this thing?
Yes.
So host name is the command, and after that, whatever name you will give, that will be the name of the switch.
Okay.
Type again host name space SW2. Till now clear?
Yes.
So in that, just minimize this thing, minimize this window. In that procedure tab, there are some activity, you perform those activity. Click on procedure. There will be task 1, task 2. You follow all these steps, right? And perform this complete activity.
Okay, so just go ahead and start with step number 1.
Yeah, follow all the steps. If you want to go into the previous mode, then you have to type exit.
Exit.
Yes, enter. Right? Again, if you want to reach this greater than sign, then again type exit. Enter. Clear this thing?
Yes.
Okay. Follow all the steps.
Okay.
If you want to explanation of any command, you can ask.
Okay. Rakesh, how do I do this part right here?
Yes. Have you done that part?
This is right here. So if you want to find a command that starts with a particular letter.
Okay. See, right now we are typing complete like show command, right?
Yeah.
If you want to use the short keyword, for example, sh, instead of show, if you want to use sh, right? So you can use sh keyword. After that, let's say show sh space version space ver space ver, enter. So short parameter will also work.
Okay.
Okay. One more thing, press space bar. Okay. Let's say type show. And you don't know after that command, right? So space, and after that, if you type question mark, so whatever commands are there after show, it will show all the things.
Okay.
Okay. So Cisco is giving, this is the best feature from the Cisco. Sometimes we are unable to remember all the commands. So through this help, we can identify all the things.
Okay.
Clear this thing. Activity, this discovery one is done.
Okay.
Any issue in this?
No, not yet. I'll let you know if I have any questions.
Okay. So just close this thing, this procedure, all these things.
I'll close it.
Yeah, close that thing, procedure. And
Okay.
close this thing also.
Okay.
Go back.
Okay, back.
Yeah, back. Leave. Back. Okay. Just refresh this window. Okay. So you can see some amount of time you utilize, and it is showing like how much is remaining now.
Yes.
Clear this thing.
Yes.
Have you run all the steps on whatever discoveries it is showing? Or do you,
On procedure?
yeah, or you miss
I
some?
didn't get through all of it.
Okay, once you put all the things, then it will show completed.
Okay.
Okay, so you can do this thing later, that is not an issue.
Okay.
Now, activity number 2, discovery number 2, basic switch configuration. So start this lab. Okay, click on procedure. So go to down. Okay, down. This host name. Okay, VLAN IP address. Okay, down. Okay, down. Initial startup configuration. Okay, down. Okay. So perform this activity. It's very basic activity, like just to verify all those stuff.
Okay.
So just complete this activity and
Okay.
perform all the steps. Whatever steps are there, perform all the steps.
Okay.
If you are unable to understand anything, then let me know.
I will. Okay. Okay, and then once I'm finished with the steps, you can just close it out.
Yeah, close that.
Okay. And I can hit back.
Yeah, sure.
Back again. Okay.
Clear?
Let's continue lab. Was there something that I might have missed?
No, maybe it will complete after certain, because maybe
Give it time.
you are typing all the commands now. So sometime it is assuming you are still working there.
Okay.
Otherwise, everything is working fine.
Okay. But it should say completed, right?
Right.
Okay.
So activity number 3, how the switch will operate. Start this thing.
Okay.
So in this basically you have to check the MAC address table, how it will work. Okay. So just be on the same page. Just stop your sharing. Let me explain that thing, and then you have to perform this activity.
Okay. So stop share.
Yeah, stop sharing.
Okay.
Are you able to see my screen?
Yes.
Okay. So let's assume we have these 4 computers and they are connecting on these particular ports 0 by 1, 0 by 2, 0 by 3, 0 by 4. Clear
Okay.
this thing?
Yes.
And every PC is having a MAC address, right? For easy understanding, I'm writing like this way: A, B,
Okay.
C, and D. So A, B,
Sure.
C, D, these are, let's assume these are the MAC addresses.
Sure.
If I want to communicate from here to here, right? So on the PC A, I type ping and 10.0.0.4. Okay. So what will happen? This packet will come to the switch. So how this switch will behave with this packet? So first thing, whenever a switch receive a frame, so switch will create a MAC address table. In that MAC address table, there is a information about I receive a frame from fast Ethernet 0 by 1. First thing, right? Then there is a information about source MAC. What is the source MAC? Source MAC is what? A. What is the destination MAC? So right now, I don't know the destination MAC of this 10.0.4 because it's a first communication. So in the first communication, there will be no information about the destination. So if there
Okay.
is no information about the destination, it will put FFFF. So it's like a broadcast. And there will be information about VLAN. So by default, we are not creating any VLAN right now. So there will be information about VLAN 1 because VLAN 1 is automatically there. Clear this first step. Any confusion?
No.
If this PCA doesn't have any information regarding the destination MAC, which is D, so it will forward destination MAC as the FFFF. So what do you mean by this FFF? Once this this switch receive this destination MAC, so it will forward that destination, that packet to all the PC, all the port. So this PC will assume this is not for me, so he will drop the packet. This is not for me, drop the packet. And this will give reply, right? So when it is giving reply, again this switch will receive a frame, right? So
Right.
it receive a frame 0 by 4 right now. What is the source MAC? D. So it is giving reply of this request, right? So it knows what is the destination MAC. So destination MAC is what? A. Clear this communication?
Yes.
Now, let us assume next time this table is in my switch right now. Next time when this PCA try to ping this guy 10.0.4, so what will happen next now? So now same way, it will receive a frame on the 0 by 1. It knows right now the destination MAC is D, right? So this time it knows destination D is present on 0 by 4. So it will directly forward that packet to 0 by 4.
Okay.
So the point is, if there is a information of the destination MAC in my MAC table, then the communication will be the unicast. If the destination MAC is not in my MAC table, then the traffic is unknown unicast. Clear this part?
Yes.
Okay. So this activity is regarding this concept. Okay.
Got
So
it.
now perform that activity.
Sure.
So share your screen so I will get to know, okay, everything is working fine.
Okay, can you see my screen?
Yeah.
Okay, cool. All right, Rakesh.
Yes.
So for right now, it says I'm in PC1, correct?
Right.
There is a way to change it, so I can stay on the same terminal and change it to PC2, right?
Right. You can change the name.
Okay. So how would I do that again? What was the command?
But why you want to change the name?
Because it's asking me to go into PC2 so I can enter in the
No, no,
the
no,
different.
no. PC2 is down. See the last option.
Oh, I
Yes.
just have to double click it then.
Click on that, and
Okay.
again there will be new terminal.
Gotcha. Okay. I didn't know we could do. I thought we could do it all in the same one, same terminal.
No, 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 no. Once you click on the device, you will get the console of that device.
Gotcha. Okay.
Okay, hold on. Right now, if you are writing this command, show MAC address table. In this MAC address is your PC MAC address, and in the type you are you've seen like dynamic. This dynamic means this MAC address is automatically learned by the switch, okay, with the help of ARP protocol, ARP. Okay.
Okay. All right. Looks like I reached the last step.
Yes.
Okay, so just close all of this.
Right.
All right, start from the next slide.
Okay. No. So in this way, you have to perform the labs. Okay. So let's discuss the next topic, IP addressing.
Okay, which one is that?
No, IP addressing is just basic theory part. Because
Oh, okay.
if you know the IP addressing, subnetting, supernetting, then only we can understand the IP part, IP routing. Okay. Are you able to open your book?
I had it up just a second ago. Let me.
I think so. I think so in Cisco account. Yes, here somewhere here. I think so.
Let me find my information.
No, this is not your user account, no?
Oh, is that?
It's better you click on that like link, whatever you got in the mail.
Yeah, that's what I'm going to check right now. Service line. What the hell?
Log in here.
What was that?
Previously, are you able to open that thing?
Yeah, no, I was logged into it earlier.
Okay, simply click on sign in.
Sign in?
Yes. There is an
Okay.
issue with the password.
Okay. Is there a way to reset the password?
Mm, you have to go, you have to show me that mail there. Click on forget
No.
password. Forget password.
Forgot password. Oh, weird. All right. We'll just reset that. Sorry.
It is telling invalid token.
Yeah. You know what that means?
Invalid token.
Hold on. Try this. Jesus.
Now you are able to log in.
Yeah. You're talking about this, right?
Yes.
Okay.
So click on this lower one, student guide.
Okay.
So this is your book. Okay.
Okay.
So click on this building simple network. Click on this plus sign. Okay, see, till now we completed this function of the networking, which is like basic introduction to the networking. Then host to host network communication, we done this part. Introduction to the LAN, we done. Operating the Cisco IO software, which is we done these 3 activity, right? That comes under this. Starting the switch, how the switch will work, like whatever 3 activity we done, that comes under this part.
Okay.
Okay. Then click on this establish the network connectivity. Click on the plus sign. Here, establishing the network connectivity. So here we have to do what introduction to this ACL. Okay, static routing. Right. Understand the IP addressing and the subnet. Okay. Okay. Leave it. Go back.
Go back as in back one page?
Yes, back one page. Back 10, no, sorry, where you are getting all the 2 books, na? That page.
Oh, okay. Here?
Yeah. Just click on this lab guide. Okay. So in this lab guide, all the labs are there.
Okay.
Okay. So you can follow this lab guide also.
Okay.
So, okay. Stop the sharing. So now we are going to discuss IP address. IP address. What is IP address? So IP address is a numeric identifier.
Are you sharing something, Rakesh?
Oh, sorry.
All right, I see.
So IP address is a numeric identifier of a device. So that device can be a PC, can be a switch, can be a router, can be a firewall, can be a load balancer. Okay. IP address is logical. Logical means IP address can be changeable. IP address have 2 parts. One is network and another one is host. We'll discuss that thing next. IP address have 2 versions. IP version 4, IP version 6. So till this point, I will just discuss IP version 4. IP version 6 we'll discuss later, maybe on the last day. So whatever we have to discuss like routing, switching, all things are based on IP version 4. So now IP version 4 is 32-bit long. 32-bit long address. Divided into 4 octet, each octet 8 bits. So understand this thing. Okay, what IP addressing you are using in your internal network? Any idea about that?
What was the question?
What IP address you are using in your inside network in your company? 192 series, 172 series, or network 10?
I believe 192.
192. So let me give that example. So let's say 192.168.1. Let's say 100. Okay. So let's say you assign this IP address to the PC. So in this total IP is 32-bit, but that is divided into 4 octet, and that octet is separated by this dot. Clear? Every octet is having 8 bits. So total 32-bit. Clear this thing?
Yes.
In every octet, there can be maximum value 256. This value in any octet 0 to 255. So if you start from 0 to 255, 256, right?
Mm-hmm.
So we are normally starting 192.168.1.0 and it will go at the end 255, right?
Mm-hmm.
Okay. One more point. IP version 4 is in decimal form. Decimal form means all the characters are there between 0 to 9.
Okay.
IP classes. IPv4 classes. So let's say, let's make this table class range. Default subnet mask. Number of valid IP. So total we have 5 classes, class A, B, C, D, and E. Okay. Class A, B, C, D. A, B, and C, these are user specific.
Okay.
User specific means user will get IP address from these range. Class D is used for multicast. Class E is for research and development. Military and scientists are using this class E.
Okay.
Class range. Class A start from 1 to 126. So I just write first octet. So it will be 1.0.0.0 till 126.0.0.0. Clear?
Okay.
Class B start from 128 to 191. 192 to 223. 224 to 239. And 240 to 255. Clear?
Yes.
Any question in this table?
No.
Okay. So I just summarize everything regarding the IP address classes. We have total 5 classes, class A, B, C. Class A, B, and C are used for user specific, means user will get IP address only from class A, B, and C. Class
Okay.
D is reserved for the multicast. Whenever you are doing the multicasting, you have to use only the class D IP address. Class E, this range is reserved for military and scientists. Normal people will not get IP address from this range. It is reserved only for military and scientists. So if
Got
you
it.
see this table, 127 is missing, right?
Mhm. Yes.
What is the use of 127 network?
Don't know.
Okay. So have you heard about like loopback testing?
What kind of testing?
Loopback testing.
No, I have not.
Okay. How you will verify your LAN card is working fine or not? In your system, type this command: ping and 127.0.0.0.1. Ping this IP address. You will get reply from.
So reply from 127.0.0.1.
Right. Are you getting reply from?
Yes.
No. What do you mean by that? See, this 127 network is reserved just to check out your LAN card is working fine or not.
Hmm.
Okay. Because if you are unable to communicate, that means maybe there is a reason your LAN card is not working fine. Okay. So they reserved this particular IP address, particular network only for loopback testing. Clear now? What is the loopback testing? Just to check your LAN card is working fine or not.
Okay.
This is for LAN card testing, also known as loopback address, also known as loopback addressing.
Okay.
Okay, next. So what is the public IP and private IP? Public IP are provided by ISP, Internet Service Provider. You have to pay. Public IP are unique. You can directly access internet. Clear?
Yes.
So whenever you are taking internet service in your mobile, your service provider will give you direct public IP in your mobile. Right?
Yes.
And these are IP are unique. Whatever public IP address you are getting throughout the world, the same public IP address will be not assigning to anyone.
Okay.
Private IP, these are free of cost. Okay. Now, you cannot access internet directly. You need at least one public IP address. Okay. Duplicate private IP can exist, but not in same network. Clear?
Yes.
So for example, in my company, I can use 192 network, and in your company, you can also use network 10. But
Okay.
if we combine this, any two branches which is using 192 network IP address, then there will be a conflict of IP address. But if those two companies are working separately, there will be no issue. Clear?
Yes.
Okay. So from every range, for example, like class A, there is a 10.0.0.0/8. From class B, 172.16.0.0.0 till 172.31.0.0/16. In class C, 192.168.0.0/24. So these IP addresses, these networks are freely used. Anybody can use. There will be no issue. So this is known as private IP addressing or reserved IP range.
I see.
Then we have classful IP. Classful IP, if an IP have default subnet mask with respect to respective class, that IP is known as classful. For example, if I'm writing 10.0.0.10 and if I use the same IP address 10.0, this classful. If I'm writing this 172.16.1.1 and the subnet mask is class B, this is the classful. If I'm writing 192.168.1.100 and the subnet mask is 255.255.255.0, classful, right?
Okay.
Classless means if an IP doesn't have default subnet mask with respect to the class. For example, if I write this thing 10.0.0.10 and if I write this subnet mask, it's a classless IP address because it is not having the same class subnet mask, right?
Yeah.
Clear this classless and classful concept? If an IP have same subnet mask with respect to the class, that IP is known as classful, and if the subnet mask is not same, then that IP is known as classless.
Okay.
How many ways to assign IP? So first thing is the static method, static IP. Another option is DHCP. Third option is APIPA.
Okay.
Clear this part?
Yes.
So you know how to assign IP address
No.
in the PC. In PC,
Okay.
you know or you don't know?
I don't know.
Okay. See my screen.
Yeah.
There is a network, right?
Hmm.
You will go to the network
Yes.
and internet settings. Ethernet. It is showing connected right now. So
Mhm.
if it right now it is having IP address, I will not change. I will just show you how to.
Oh yeah. Okay.
Right now it is getting this IP address, right?
Right. You can also change it like in the control panel, correct?
Yeah.
Yeah. Okay. I've done that before.
Okay. Second option is DHCP. If you put your IP address in obtain an IP, automatically it will get IP address from the DHCP.
Okay.
APIPA. APIPA is automatic private IP addressing. Automatic private IP addressing. Now, what is this? Let's say you are not putting any static IP address and you don't have any DHCP in your network. So your PC will automatically get IP address from this network. Last two digit can be anything. Have you seen this IP address?
Yeah.
Right? So this is the APIPA IP address. Clear?
Okay. Yes.
So now the question comes, who is assigning this IP address? Your DHCP or anyone? Because that IP will come only in that case if there is no static IP, there is no DHCP.
Okay.
Then the point is, who is assigning this IP address?
The network.
No. Operating system.
Operating system. Okay.
Okay. Because network means your NIC card, and your NIC card is not having any operating system. So if it doesn't have any operating system, then how we can provide the IP address? Right? Another question. Let's say if you have a APIPA IP address, I have a APIPA IP address. Can we communicate?
No.
No, we can communicate.
You can't communicate.
Right? But locally in the network.
Okay. So only locally.
Yes. So what is the benefit of private IP address? Because private IP address is also used locally in the network. APIPA we can use locally in the network, right?
Mm-hmm.
So the difference between the APIPA and the private is through APIPA IP you cannot access internet anyhow. Clear? But
Yeah.
internally, if we have the private IP address, we can do netting, and through NAT we can access the internet. But NAT option is not available for the APIPA. Getting my point?
Yes.
So this is all about IP addressing. Any question till now?
No. No question.
Okay. So next we have to discuss subnetting and VLSM. And after that, we'll move to the routing part. So let's take the lunch break now or after 1 hour.
No, we can take it now.
Sorry?
We can take it now.
Okay.
So we'll meet back at in 1 hour.
Yeah, sure.
Okay, sounds good.
Oh, okay. So hello.
Hello, okay.
Yeah, let's start. So next topic is subnetting.
Okay.
How much you are good in the mathematics?
I'm all right.
Okay, because this topic is totally depend on mathematics.
Okay. Like basic math or?
Christopher, there is a lots of disturbance from your side. It's like through mic or what?
Yeah, I'm trying to put my sorry. I'm trying to put my headphones in.
Okay.
That's all right. You able to hear me?
Yeah.
Okay.
Are you able to see my screen?
Yes.
Subnetting is a process to divide a huge subnet into smaller subnet. Subnetting always implement on host part. Subnetting divide broadcast domain. Provide segmentation of the network. It provides security. Security in which sense? Let's say this is my network. In this network, I have 192.168.1.0/24. Let's say I have this subnet. If I assign here .1, .2, .10, .20, .40, .50, .60, .100, let's say. Okay. So tell me, can all these computers can communicate with each other?
Yes.
Okay. They can communicate with each other because they belongs to this IP subnet.
Right.
But if I want that type of configuration, let's say in my network, in my company, I have sales department, I have account department, I have finance department, and I want like this. Means, let's say this is sales, this is IT, this is account.
Okay.
I want sales user can communicate with each other, but sales user will not communicate with any other department.
Okay.
So one option you have here, you can put different subnet, different subnet, different subnet. Your requirement will be complete, right?
Right.
But in that case, there will be the wastage of IP addresses. How? Let's say in this example, in the sales, I have only 2 computers. So if I use here a different IP subnet, what will happen? So more than 250 users will be waste, right?
Sure.
So we can use this subnet and we can divide this subnet into smaller subnets, so
Okay.
that within the department there will be communication, but outside the department there will be no communication by default. If you want
Okay.
to communicate that thing, then you need router, and on the router you have to do routing process. Clear this point?
Yes.
Now let's take an example. For example, 192.168.1.0/24. This is my network. It's a single subnet, right?
Right.
In this, IP address will start from 1.1. What will be the last IP? 1. Last IP 254 or 1.255. What will be the last valid IP?
255.
No. 1.1 to 254. This is known as valid IP.
Okay.
In any subnet, the last IP will be the broadcast IP.
Okay.
Now, what is the use of broadcast IP? If I send any information to this broadcast IP, that information will be automatically distributed among this network,
Okay.
right? So let me give you a basic example. Let's say there is a computer which is having any IP address. If I communicate 192.168.1.255, if I ping this thing, ping this IP address, so what will happen? It will forward this request to all these 254 users, and you will get reply from all those 254 users. It will broadcast actually that information. So if you send any information to the broadcast address, it will forward that information to all the valid IP addresses. Clear this part?
Mm-hmm.
Okay. So that means they can communicate with each other because they belongs to this IP subnet. Now, my requirement is, previously this is a big IP subnet. I want 6 logical subnets in this. Clear this thing?
Yes.
So my requirement is 6 subnet, means I have to divide this network, one single network, into 6 logical subnet, first thing. So this is my requirement. After that, you have to identify how many hosts will be there in every subnet. Clear?
Yes.
Okay. So how you have to do this task? Now, So which class IP is this?
This right here, it's subnet, right?
Yeah, this IP address, this subnet belongs to which class? Class A, B, or C?
Uh,
It belongs to class C. Let me show you that table. Yes, if you see this table,
oh, okay.
192, right? So 192
Yeah.
belongs to class C. And in this, there are 3 network and 1 host, right?
Mm-hmm.
No, it's a class C. So class C means this is the network part, network part, network part, and this 0 is my host part.
Okay.
My requirement, 6 subnet. Now, there is a point you have to implement subnetting always on host part. So this 0 is my host part, right?
Mm-hmm.
How many bits are there in this host part? Remember?
I did not list the.
8 bits. 8 bits. Every octet is having 8 bits.
Okay.
So I'm writing host 8 bits like this way. Whenever you have to count the network, you have to count from this side, and when you have to count host, you have to count from this side. Clear this point.
Yes.
Every bit is having a default subnet mask 1, 2, 4, 8, 16, 32, 64, 128. This is the default subnet mask on each and every bit. If all these bits are used, then you will get 255. Clear?
Yes.
Now, remember these 4 points, simple 4 rules. First thing, you have to create 6 subnets. So first thing, find out number of host bit for required subnets. So there is a formula 2 raised to power n. So 2 raised to power n greater than equal to your requirement is 6, right?
Yes.
So what will be the value of n here? Can you solve this thing? 2 to raise power how many? 1,
So it has to
2,
be greater or equal to 6.
yes.
So would it be 3? Okay.
Clear this thing? So here you are getting 8. Your requirement is 6, right? But with the calculation, it is coming 8. Why? Because if I put 2, then it will be 4,
Only 4, yeah.
right? But my requirement is 6. So I cannot
Okay.
take lesser than my requirement. If it is
Okay.
going more than my requirement, that's okay. But it will be not like more, like if I take here 5, again that 5 will be not feasible because there will be too many networks, right? So
Mm-hmm.
you have to always take nearly equal to.
Okay.
This point clear, first thing.
Yes.
So what do you mean by these 3 bits? 3 bit means 1, 2, 3. Because you have to count network bit from this direction. Clear?
Okay.
By default, there are 24 bits. And 3 bit more, 27. Clear? So your
Yes.
new network will be on /27. Second point. Number of valid IP. So there is a formula 2 raised to power n node minus 2. And node means remaining bit. How many bits are remaining now?
6, right?
5. Total 8. 3 bit are already in used. Clear this thing.
No. Yeah. So
1, 2, 3, 4, 5.
okay.
So what do you mean by this? Let's say previously this is a big IP subnet.
Okay.
Now this is logically divided into 8, like this way.
Right.
These 8 are different departments, and according to our calculation, every department will get 30 user. Now clear?
Yes.
Third point. Calculated subnet mask. Calculated subnet mask. Now 256, sorry, whatever bits are used to create the network, you have to add the default subnet mask of those bits. So 128 plus 64 plus 32. You use only these 3 bits, right? You will
Okay.
get to 24.
Okay.
Fourth point, block size. For the block size, you have to subtract your subnet mask from the full octet, which is 256, and you will get 32. So 32 is your block size right now.
Okay.
Any confusion in these 4 points?
Yeah. So can you go over number 3 one more time?
Okay, number 3. See,
Yeah. Number 3.
first, in the first step, we just identify how many bits are required to complete our requirement. So first step, we identify, okay, 3 bits we required. So from
Okay.
the 8 bits, 3 bits are used for creating the network, and rest of the 5 bits are using for host. Now, subnet mask always comes from the network bit. So by default 24, right? So 24
Right.
means 255 first octet, 255 second octet, 255 third octet, and host octet is 0 as it is, right?
Okay.
So 24 bits are these, and 3 bits now these. So you have to just add what is the default subnet mask on those. So it will come 224. So 224 means 255.255.255. This is fixed, right?
Yeah.
And in the last octet, it is 0 previously, but now how much? So this is your new subnet mask. Getting now?
Yes.
Subnet mask always comes from network bits. Remember this point. And after that, block size is used for after how many IP address you will get a new subnet. So whatever subnet mask you receive, you have to subtract from the 256. Why 256? Because in every octet, maximum value will be 256, 0 to 255, right?
Yeah.
So from here you will get 32. So how your network will go? Your first network will be 192.168. How much? 1.0? I think so, 1.0. right? Then another one will be 192.168.1.32. Another one will be 192.168.1.64. Another one will be 192.168.1.96. So it will be up to so on. And how many you will get? 8 subnets you will get.
Okay. For each one, right?
Yes. So in this subnet 192.168.1.1, this will be the first valid IP.
Okay.
It will go till 30. Dot 31 will be the broadcast IP. Right?
It's always going to be .31 will be a broadcast.
Right. Same
Okay.
way here, 192.168.1.33 will be the first valid IP. It will go till 62.63 will be again the broadcast IP.
Okay.
So in every subnet, you will get one broadcast IP. And you can see you are getting the 30 number of user every day.
Okay.
And what will be the subnet mask? By default, it is 24. 24 plus 3, 27. So everyone will be /27.
Well, why is it +3?
Sorry, why?
You said 24 plus 3. Where's the +3 coming from?
That +3 is coming from here. From here.
Oh, okay.
Clear?
Yes.
Any confusion in this example?
Little bit, but I'll catch up.
So, do you have notepad and pen with you?
Notepad and pen. Yeah.
So just show me one thing. I'm giving you 192.168.1.0/24. This is the major subnet. In this,
Okay.
you have to calculate for 30 subnets. Okay, this is your
Okay.
task. So try to solve this thing and let me open all the steps so that, okay. This is the example which I solved. Okay,
Okay.
follow this example. What you have to do, this requirement previously we solved for the 6. In your case, it is 30.
For 30.
30, right? So calculate according to this.
Okay.
So try
What was the
to,
IP address again?
sorry?
What was the IP address?
Same, 192.168.1.0/24.
Okay. Okay, and you said for 30 subnets?
Yes.
So it has to be 2n greater to or equal to, instead of 6, it's 30, right?
Right.
Okay, so let's do. All right, Rakesh, I need some help. I'm a little lost.
Yes, tell me.
Okay, so I mean, the answer that I got, I don't know if it's right though, but is it 248?
Yes, correct. Your
So,
subnet mask will be 255.255.248, right?
so okay, so you were supposed to find, okay, so the number of the host bit for the required subnet. So that has to be to the power of equal to or greater than 30, right?
Yes.
Okay, so that was 5.
Right.
And the number of valid IP is 2 to the nth power minus 2. So that will come out to
3. 2 to raise power 3 minus 2.
power 3 minus 2?
3. Because 5 bits are used for the network in the first point, right?
Yeah.
So total bits are 8. So from 8 bits, 5 bits are used for network and 3 bits are for the host.
Oh, okay. All right, so 248 was correct?
Yes, 248 is correct.
Okay. Now we got to figure out the block size.
Yes, block size will be?
Block size will be... Is it 8?
Yes, correct.
Okay. Yeah, I told you my math's not that good, man.
So your block size will be 8, right?
Mm-hmm. Yes.
And valid IP will be 6, network will be 30, right?
Yes. All right, is there something else that I need to find?
Yes.
What else am I supposed to figure out?
Sorry?
What else do I need to figure out?
Actually, this is the normal procedure, right? In the exam, there will be 3 questions from this section, like subnetting, supernetting, and VLSM. So whatever process I tell you till now, that is the normal process. Just to identify or like to understand this subnetting, right? Now I am telling you how the question will come in the exam.
Okay.
So in the exam, they will create a scenario, okay, like this way. Let's say here there will be 30 user, okay, and they will give you a network 198.168.1.0/24. Subnet can be any, right? Here they can tell 60, 26.
Okay.
So here they will write some subnet, right? And they will ask what will be the subnet here. Okay, so you have to identify what will be the subnet here, in which you are getting 6 hosts.
Right.
Right. So that kind of question will be in the exam.
Okay.
Till now clear?
Yes.
Okay. Now in C class subnetting, you can use maximum 6 bits of host. Now you cannot use 7th bit. Why? Because if you create the network with the 7th bit, so what will happen? 2 raised to power 7 minus 7 will be 128. But when you calculate the host, so 7 bits are used to create the network and only 1 bit is remaining now. So if you calculate the host, 2 raised to power 1 minus 2, that will be 0, right?
Right.
So there will be no benefit of such network in which you are not getting the number of hosts. So we can say in C class, we can use maximum 6 number of bits, host bit. If you want more network, then you have to go class B. Clear this
Okay.
point?
Yes.
So let's take a class B example. Class B. So if you remember, in the class B, there are 2 network part and 2 host part. So that means 16 bits are from the network and 16 bits are from the host. Clear?
Yes.
So let's say 172.16.0.0/24. Sorry, /16. In this is a network, host, and host.
Okay.
So right now we have 16 host bits. So I can write like this way: 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Okay.
Default subnet mask 1, 2, 4, 8, 16, 32, 64, 128. This
Okay.
is another octet. So same way 1, 2, 4, 8, 16, 32, 64, and 128.
Okay.
Now let's see, in this our requirement is 100 subnet.
2. Okay.
Okay, this 100 subnet we cannot do in class C, so we have class B. Same way, find out host bit for required subnet 2 raised to power n greater than equal to 100. So what will be the value of n here?
Formula. Okay. So it would be
7.
okay. So yeah, 128.
Right, because if you take 6, so that will be 64. Your requirement is not completing, right?
Right. Right. Not enough. Okay.
So that means
Yeah.
7 bit means 1, 2, 3, 4, 5, 6, 7. You have to count network from this way. Remember this point.
Okay.
Host from this way, right? So these 7 bits are used. Second point, valid number of host 2 raised to power n node minus 2. So what will be the value of remaining bits? what will be the value of 9?
Okay.
8 plus 1, right?
Yeah.
510.
Wait, how did you get that again?
8 total bits are 16, right?
Yeah.
So 7 bit we already used. So how many bits are
Okay.
remaining? 8 plus 1.
9.
Third, calculated subnet mask. So if you add all these value, you will get 254.
Okay.
If you add all these 7 bits. And this last octet is not in use, right?
Right.
We haven't used any bit. So you have to put as it is 0. Any confusion?
No.
No. So what will be the subnet mask? This will be the default 16, and after that 254.0. That will be your new subnet mask now. Last, block size. So same way, 256 minus 254, you will get 2.0. So your network will grow in the increment of 2.0.
Okay.
Okay. So normally you should know this process, because if you are in a network designing team member, then you have to do all these tasks. But no need to do all these calculation. If you go into the Google, there will be a software. IP subnet calculator.
Oh, okay. Before the exam, you'll need to do it by hand, correct?
Yeah, just only for the exam practice you have to do manually. But
Okay.
if you are in the production environment, it's one single click and you will get all the things. For example, we have class B address, right? Our network, okay, let's say subnet mask this. IP address start from this range. Subnet bits. Subnet bits, let's say if I have in our case 7, right? We use 7 bits.
Yeah.
So subnet mask will be on slash this. 510 host R will be there. It start from this. Clear? That will
Yeah.
be the calculation like this way.
Okay.
So there will be a this subnet calculator. There are some tool, let's say advanced subnet calculator. You download this thing, you just put the value, and within a minute they will calculate everything, and you will get a complete sheet in which all IP subnet will be there, IP addressing will be there, what will be the broadcast address, everything will be there.
Okay.
So this process you have to just remember only till the exam.
Okay.
So same way you can do in the class A also, but class A is not required. Why? Because only the calculation task will add, means what will be the value of 2 raised to power 22, all those stuff.
Okay.
But rest of the things will be same. Okay, so we done with the subnetting. Is there any
Okay.
problem? Is there any problem in the subnetting process?
I mean, a little bit of things. Just I need a couple more things just to be a little bit more clarified, but we can come back to that.
Okay, cool. But my question is,
I got it.
if I implement this subnetting in the production environment, I will get any problem, or it is good for the network?
It's good.
But there will be a issue. What will be the issue? If you see in the calculation, in every subnet, there will be equal number of users, correct?
Yeah.
But in the network, let's say how many HR you have in your company? Maybe 2, 3, 4, 5, 6, not like 50 or 60, correct?
No. No.
So if you calculate, and if you are getting in every block, there are 30 users. So that means that HR department is also getting the 30 user.
Mm-hmm.
And actually you have only 5 users, 5 HR. So there will be the wastage of 25 IP, right?
Yeah.
Maybe you have a sales department. In that sales department, you have 60 users.
Yeah.
But according to the calculation, it is coming only 30 users. So again, that calculation is not fit for your requirement.
Yeah.
So subnetting fail in that type of scenario if you have unequal number of the users.
Okay.
Clear? So now
Yes.
what is the solution for that? So solution is VLSM. Variable length subnet mask. It reduce wastage of IP addressing. It is useful in such network where we have unequal number of users in every department. Right?
Yes.
So VLSM is used to reduce the wastage of IP addresses. Provide a scalability to network. It provides security again, always implement on host part. Similar to your subnetting.
Okay.
Okay, but remember, subnetting is done according to network requirement, how many networks you require. VLSM is done according to host requirement. Whereas subnetting is done according to network requirement.
Okay.
Remember this point. So according to network requirement or host requirement means, firstly subnetting. So subnetting means you will get a subnet and they will tell you, okay, how many subnet you want to create, how many department you want to create. So you will do the subnetting. But VLSM is done according to host requirement means how many users are there in a particular network. So based on that, you have to do the calculation task. Clear?
Yes.
Okay. Let's take an example. These are the routers. Let's say R1, R2, R3. This is connecting with a switch. Let's say here we have 25 users.
Okay.
Here we have, let's say, 60 users. Here, let's say we have 30 users. Here is 2 and here is 2 users. Because if you want to communicate these two routers, one IP is required here and one IP is required here, correct?
Correct.
So, and I have a subnet 190. My subnet is, let's say, 192.168.1.0/24. This is my major subnet.
Okay.
So now here we have the different requirement everywhere. So in this case, I cannot implement subnetting, because if I implement subnetting, so how many networks are there? 1, 2, 3, 4, 5. So it will become my first question, in which I gave you 6, right?
Mm-hmm.
If you remember, in that number of valid host is 30. So valid host 30 will be suitable here and suitable here, but not suitable here in these 3 networks.
Right.
There will be the wastage of IP address, and where is the 60, that will be not suitable.
Yes.
So in this kind of situation, you cannot use subnetting. You have an option which is called VLSM, variable length subnet mask. So how you have to do that task? So in VLSM, you have to calculate subnetting only, but in a different manner. Okay. Christopher, just give me a minute. Let me take a glass of water and then we'll continue. Okay, just a
Okay.
minute. So in this kind of scenario, you have to find out what will be the suitable network in this network. This is your major subnet. So what you have to do, requirement, and this time it's a host requirement. Okay,
Right.
block size and CIDR. CIDR is classless interdomain routing, right? So whatever this kind of notation is known as class CIDR notation with the slash value. Okay, so whatever
Okay.
subnet we are writing with a slash, that is known as CIDR notation. So first thing, you have to note down your requirement either in the ascending order or descending order. So it will be good if you are going into the highest first value. So my requirement is 60, after that 30, then 25, and then 2, right?
Okay.
You have to identify these values. So I'm calculating for let's say 60. So you will get one idea. So this is the 60 user,
Right.
right? So the calculation is just reverse. So for example, previously my first point is identify the number of host bit for the required subnet, right? But this time I'm not creating the network. I have host information. So same information you have to use. It's a class C address, right?
Yeah.
So again, we have 8-bit. So first thing, host. So for host, my formula is 2 raised to power n node minus 2, right?
Yes.
So again, if I solve 2 raised to power 6, I will get how much? 62, right?
Okay.
So if 6 bit are for the host, how many bits are remaining for the network?
2.
2, correct. So 2 raised to power n, 2 raised to power 2 will be 4. If 2 bits are used for the network, what will be the subnet mask? So 128 plus 64, correct this thing, any doubt? Because subnet mask always comes from the network bits. So these 2 are the network bits, 6 are the host bit.
Okay.
Okay, actually in this example, your first point becomes second point and second point become first point. This is only the change. 192. Then last point, block size. So for the block size 256 minus 192, you are getting 64.
Okay.
So for the 60 user, the block size will be 64.
Okay.
And the slash CIDR value will be slash 26. Why 26? 2 bits from here and by default 24 bits, correct?
Mhm.
If I calculate for the 30, same way, you will get 32 slash 27, 32 slash 27. It will be block size 4 slash 30. These value will come.
Okay.
If you have any doubt in any value, I can explain individually. You just tell me.
Okay. So for the host requirement, that's 25. So it would be 32 because it's greater than or equal to, right?
Right. Same way.
Okay. All right. Yeah, that makes sense.
Clear this thing?
Yeah.
So you identify how this value will come.
Yes.
Okay. Okay. You want that calculation here?
Yeah, if you can leave it on there, that would help.
Uh, 60/30. Okay. Let me make another one. So we have this scenario. Here is 25, 30, 60, and 2 and 2. Now, so how the subnet will come? So based on the previous table, so our IP address can be from 0 to 255, right?
Yeah.
So for the 60, we have a block size 64. So let's say 0 to 64. So we can allocate that network here. For example, here I can assign 192.168.1.0/26. It will go till 63. Clear this thing?
Why would it go to 63?
Because 64 is the next subnet, na?
Yeah, okay.
So last IP will be 63, which is the broadcast IP.
Gotcha. Okay.
Now, then we have 30 and 25. So these are having 32 block size, right?
Mm-hmm.
So if you add 32 here, that will be 96.
Mm-hmm.
Again, if you add, you will get 128, right?
Right.
So here I can assign, for example, 192.168.1. Start from 164, it can go till 95, and that will be /27.
Okay.
Here I can assign 192.168.1.96/27, and it can go till 127, right?
Right.
Here I can assign 4 block size. 4 block size means 192.168.1.128/30. It can go till 131, right?
Right.
And here I can assign 192.168.1.132 135/30. 132 136. So till, let's say, D and E. So here you can say I put E subnet, D. This is my, let's say, A,
Mm-hmm.
A, B, and C. Right? So if you see, this block is completely free. Whatever subnet I required, I can allocate. Means my requirement is 64, I can choose 64 subnet. My requirement is 32, I can use 32. So this is
Mm-hmm.
totally free. But same thing, if you done with the subnetting, you are not getting these free IP addresses. So VLSM is used to reduce the wastage of IP addresses. Clear?
Yes.
Okay. So this is the part of IP addressing, subnetting, VLSM. Now, router and IOS. Are you able to see my screen? Correct?
Yes. Mm-hmm.
Okay. So first thing is Cisco IOS. What is Cisco IOS? Listen, router, switches, firewall, these are the hardware. Inside the hardware, there will be a software, and that software is known as IOS.
Okay.
IOS is a inter-network operating system. So you can say this IOS is the software image of that particular hardware. This IOS is a Cisco proprietary keyword, inter-network operating system. So what is this IOS? Cisco technology is built around the Cisco inter-network operating system, which is software that control the routing and switching function of the inter-networking devices. Your inter-networking devices are your router, switches, firewall, load balancers. So normally, basically your IOS will provide you the functionality of routing, switching, security, all those functionality. Clear?
Yes.
Now, so router is a layer 3 device which you already discussed. Router will provide you the routing, and router main task is to identify the best path. If you have multiple paths to reach a particular destination, then this router will identify which path is the best path, and it will put that best path into the routing table. So your traffic will follow that particular best path.
Okay.
Now, component of the router. If you open the router, so basically routers are coming into two model. First thing is non-modular and another one is the modular. Non-modular means, have you seen any router, any series?
Yes.
Which model you have seen?
I've seen like Netgear and stuff like that.
Netgear, these are the like wireless and normal models.
Yeah.
ASDM modems, right?
Yeah.
Routers, for example, like your Cisco 2600 series, 2800 series. Have you seen those things?
Okay. Yes.
So if you see in the 2600 series, that router is a non-modular router. Means you cannot. It is a. It is not a chassis base. Means you cannot increase the number of modules there.
Okay.
Right. Fixed port everywhere. So all the ports are directly connected on the motherboard. So that motherboard is having RAM, NVRAM, flash, ROM, and all the interfaces.
Mm-hmm.
So these things you can say these are the component of the router. So first thing is ROM, random access memory. So ROM is like your BIOS. What BIOS is doing in our laptop or in PC? BIOS. Have you boot your laptop with the, like, let's say sometime if you put a CD, then it is not starting with the CD. Then you will go to the BIOS and you will change the priority.
Correct.
Correct? So
Mm-hmm.
that functionality you are doing with the BIOS.
Oh, okay.
Same type of functionality is there also. Right? So ROM is basically a mini IOS in the router.
Okay.
Which perform two functionality. One is the bootstrap and another function is the post. Bootstrap means, let's say if you have multiple images or your software image is present on any centralized location. So you can tell, okay, if you want to boot, then boot from that particular image. That is a bootstrap program.
Right.
Post is the power on self-test. Any idea about post?
No.
Whenever you start your device, your laptop and PC, the post process happen first. Post, whenever you start the device, firstly power supply will go to the motherboard, right?
Right.
Motherboard to BIOS.
Okay.
That BIOS is having all the information, how many ports are present on the device. So once power supply goes to the BIOS, that BIOS will forward that power supply to all the ports. So power supply will travel to all the interfaces, all the ports, and it will return back with the information all the interfaces are working fine or not.
Okay.
This process is known as post process. If you want to verify this thing, then I will give you the simple example. When you start your device, let's say your desktop, don't connect your mouse. So if you not connect your mouse, let's say there will be in the desktop, there will be no USB mouse or no PS2 mouse. Then once your device will start, so it will give you the information pointing device is missing, correct?
Correct.
So that pointing device is missing. That means this mouse is missing. So that information is coming through the post process. Any confusion in the first point, ROM?
No.
Then next one, I am discussing RAM. What RAM is doing in your laptop? Basically, RAM is like providing speed to your device, or the running configuration save on RAM. Running configuration, for example, you are writing some notepad, right? You haven't
Right.
saved anything, right? Till the point you are writing, everything will be into the RAM.
Right.
Once you save the data, that will go to the permanent memory, which is your hard drive.
Correct.
So the RAM, random access memory, it holds the routing tables in the router. It stores the running configuration of the device. So whatever you are running, you are configuring anything, but that configuration is not saved. That configuration is known as running configuration. If you are writing anything and power off, power goes down, then all the data which is present on the RAM, that will be lost.
Okay.
Then next one is NVRAM. NVRAM is like a permanent memory. In the router, we don't have 1 TB or 2 TB hard drive, because router task is not to store the data. Router is having the routing table or the startup configuration file, which is into the KB. Okay, maybe maximum 10 KB or 100 KB. That's it. It is not having that much of big data. So there is a chip on the motherboard which is known as NVRAM, non-volatile RAM. So it holds the startup configuration. So once you save the running configuration, that configuration will become the startup configuration. Okay, and the startup configuration will store into the NVRAM. Configuration register. The by default configuration register value is 0x2102. 0x2102. So this value will be used to reset of the password of the device. Let's say you set some password on the router and you forget that password. So how you will reset? You can reset through this configuration register value. I will show you this practical. Contents are kept on the reload. If power lost, device reload, the content will be not erased, because that content is saved right now. Clear? Last component is the flash memory. So flash memory hold the IOS image. Again, it's a kind of chip which contain the IOS image. Clear this thing?
Yes.
So there are 3 points. RAM hold the running configuration of the device. NVRAM, it hold the startup configuration of the device. Flash memory hold the IOS image.
Okay.
Clear this thing?
Yes.
Any confusion?
No.
So here they are explaining the same thing. Read-only memory, it maintains the instruction of the power on self-test, post-diagnose. Store the bootstrap program on the basic operating system software. Means if you have the multiple software, multiple images, so it will give you the information, okay, on which image you want to boot up the device. And it holds the mini IOS. It holds the mini IOS means, let's say your image is corrupt. Okay, you are working on the device and the image is corrupt and you want to repair that thing. So there is an option through the mini IOS, you can repair that thing.
Okay.
RAM, it store the routing table, it hold the ARP cache, perform the packet buffering, all those things. Content will be erased if the power is off. NVRAM, same thing, it hold the startup configuration. Contents will be not lost if your power goes down. Flash memory hold the IOS image. It's a EEPROM. What do you mean by EEPROM? Electronically erasable programmable ROM. Means through the electrical signal, you can erase the complete flash and you can rewrite. let me give you an example. There is a rewritable CD, correct?
Yes.
So what is the use of rewritable means? If some data is there, you can erase that data, and after that you can re-put the new data, correct?
Correct.
So this flash memory is a chip. Let's say in this, I have a operating system which is 12.4 version. But right now we have 15.x. If you want to upgrade the image, upgrade the software, then what you can do, you can remove the previous one and you can put the new one. So whenever you are putting the new image, it will tell or it will ask, do you want to remove the previous one? So you will select yes. So it will erase previous operating system and will put the new image through the electronic signals. So that's why it is a EEPROM. Any point you want to ask here? Read all the points. If you want to ask anything, you can ask.
Correct. You'll be sending me a copy of this presentation, correct?
I will share, that will be not issue.
Okay, cool. We'll read over this again.
Okay. But again, this is not for ICND1, it's for whole CCNA.
Correct.
Okay. So maybe if you read this PPT, then you will identify, okay, this point I miss. So if I miss, it not means like I left that point, because that is not in ICND1. But
Right.
you read that thing. If you have any issue, I will update that thing. Clear? That
Okay.
will be not issue. Okay. Interfaces. So for the interfaces, let me show you one picture so you will get. This is the Cisco router 2600 interfaces.
Okay.
Okay. By default, if you purchase any 26 router, 26 and more than upper series, 26, 28, 35, right? All those routers, if you purchase, by default, you will get only 3 interfaces: Fast Ethernet, console port, and auxiliary port. Fast Ethernet, console port, auxiliary port. These serial ports are the additional ports which you have to purchase from the market and you have to plug into the device. Clear that thing?
Yes.
So by default, there will be Fast Ethernet, console, and auxiliary port. In some new devices, you will get a management port also. You will get a management port also. Okay. MGMT0. Now, firstly, let me explain this console port. Console port is to connect or to configure the device through the console port. So here you will connect the console cable. So RJ45 connector will be here and the COM port will go to your PC and you can configure through the console port.
Okay.
So console port means you are directly connecting to the device. Right?
Correct.
Then next one is auxiliary port. Auxiliary port is for remote connectivity. So it will be like this way. This router auxiliary port will connect to the modem, ADSL modem, and that ADSL modem is connecting to the service provider. Somehow you are accessing your modem, and through modem you can access this router. Okay.
Yes.
So this auxiliary port is again remote connectivity, but right now no one is using this type of connectivity. Everyone is using management port. Fast Ethernet port are used to connect router to router, first thing. Second point, router to switch. There are some conditions in which you can connect router to PC also. Clear?
Yes.
Okay. Router to switch. Which cable will be used? router to switch. We discussed before lunch, straight cable or cross cable, right?
Oh, okay. So it will be straight cable?
Exactly.
Okay.
But there is a exceptional case. If you are connecting router to PC directly, router to PC, then there will be a cross cable only in this situation, otherwise no.
Okay.
Okay, but if you are connecting router to switch to PC, in that case straight cable. But if you are connecting router to PC directly, in that case there will be a cross cable.
Okay. So if it's directly to PC, you have to use cross.
Right.
Okay.
Now, serial ports. These serial ports are used to connect router to router. Okay.
Okay.
If you see, these both ports are serial ports, but what will be the difference between them? Here, the size is small.
Yes.
These small size ports are known as smart serial ports, and this is known as serial port. Okay. There
Yes.
is a, right now in the new devices, you will not get this big interface, right? Everywhere you will get only this smart serial ports.
Yes.
Okay. So as I discussed, RAM hold the running configuration, flash hold the iOS image, and NVRAM hold the running configuration of the device. So firstly, router power on or boot up sequence means how the router will be boots up. So first thing, whenever you power on the device, firstly the device will perform the post process, power on self test. So once you power on this device, then firstly the power supply will go to the motherboard to the ROM to the all the interfaces, and it will verify all the interfaces are working fine or not. If any interface is damaged, then it will give you the information, okay, this particular interface is not working properly. Clear this thing?
Yes.
Once the post process is done, post pass, then it will run the bootstrap code. So it will identify, is there any other images there? So if there are more than one image, then it will ask like, okay, on which image you want to boot up. Otherwise, your device will be boot with the default image. Once the device will boot, then it need the iOS image. So it will load the image from the flash, because my flash is having all the images. Once image is loaded, software is loaded, then it look for the running configuration or startup configuration. So your startup configuration is on NVRAM. So it will go to the NVRAM and it will check, is there any startup configuration? If there is a startup configuration, it will boot the device according to that. If there is no startup configuration, then it will ask, do you want to configure this thing? This is known as like loading the configuration.
Okay.
Clear this thing?
Yes.
Let me check. This GNS3 is a software for like CCNA and CCNP practice, right? It's advanced software. I will tell you about this on the last day.
Okay.
We have two software, which is GNS3 is advanced, and before that you can use Cisco Packet Tracer.
Okay.
So if you start this device, so this right now it is decompressing the image. So this is actually the booting process. Okay. So if you see, this information is the booting process. This it interface information, everything that is coming under the booting process. Clear?
Yes.
Now, so if you see here, my version is 12.4. This is the internal picture of the router 2600 series. So power supply, fan, all the chips are there. Okay. So these are the DIMM and SIMRAM. So connectivity will be like this way.
Okay.
Device and device to the PC. So auxiliary port, if you see, auxiliary port to the modem and modem to the additional device. So RAM, running configuration, NVRAM, startup configuration, flash, iOS image.
Okay.
Router configuration. So same mode, if you remember, if you have greater than sign, that is the executive mode, user or enable mode, then hash, privilege mode, global configuration mode.
Okay.
If you want to configure anything, then you have to specify the interfaces. So for example, let me give you a small lab so that you will identify all the configuration. So right now I connect with fast Ethernet is connecting to the fast Ethernet 0 by 0. It can be any interface. Okay. So whatever interface is there, you have to configure IP address on that interface. Clear? But remember one thing, between a link, there will be same IP subnet. Between a link, there will be a same IP subnet. For example, here I want 192.168.1. Let's say 0/24. This is my subnet. Here I want to assign 1 and here I want to assign 2.
Okay.
See, firstly, I am configuring router number 1. So firstly, show version. So you can see like version is 12.4.
Okay.
Next command we show run, or if you tap show running configuration. So this command will display the current running configuration of the device. So right now we haven't configured anything. So that's why you can see here there is no IP address anywhere.
Okay.
Show startup configuration. Same way. Once you save the configuration, your running configuration will become the startup configuration. That's why the output will be approximately same. Your running configuration and startup configuration. Clear this thing?
Yes.
If you save anything in your running configuration, that will become the startup configuration. Next.
Okay.
Show IP interface brief. So this router is having all these interfaces: fast Ethernet 0 by 0, 1 by 0, serial 2 by 0, 2 by 1, 2 by 2, 2 by 3. And it is showing IP address is unassigned. That means we haven't assigned any IP address.
Right.
Okay means the port is okay. Method is unset. Unset means we haven't defined like it's a static IP address or it will get IP address via DHCP. Status administratively down. Administratively down, we manually put all these interfaces shut down. So once you configure the IP address, you have to enable those interfaces. By default, they are shut down. Protocol down. So we'll discuss that thing. So first thing, if you want to configure the IP address on fast Ethernet 0 by 0. So firstly, you have to go to the particular interface mode. So interface fast Ethernet 0 by 0. Firstly, you have to go to the config T, and after config T, you have to go to the interface fast Ethernet 0 by 0. Clear this thing?
Yes.
Now see the difference. So you are getting config-if. That means you reach to the interface mode.
Okay.
Here, if you want to assign IP address, the command is IP space address. And whatever IP address you want to define. For example, 192.168.1.1.
Okay.
Space 255.255.255.0. So firstly, you have to go to the interface, and after that, you have to define the IP address.
Okay.
Clear? After that, you have to run this command: no shutdown, and exit. Exit. So again, run show IP interface brief. See the output.
Okay.
So you assign IP address here. Method is manual. If it get the IP address from the DHCP, there will be a DHCP. Up,
Okay.
up. Let's see on the 2. Show IP interface brief.
Okay.
Same condition, there is no IP address.
Right.
But what you can do, interface fast Ethernet 0 by 0, IP address 192.168.1.2, 255.255.255.0. Typo.
Oh, okay.
And no shit. Exit. Show IP interface brief.
Okay.
If you want to test the connectivity, you can type ping 192.168.1.1. Clear?
Yeah.
R1. So here you will get this exclamation sign. That means everything is working fine or not.
Okay.
Clear this thing?
Yeah. So that was the IP address for R1, correct?
Right.
Okay.
So regarding this, there is a lab discovery number 6. Complete this lab.
Okay.
Discovery number 6.
Just going to start with Cisco router configuration.
Right.
Okay. Do you want me to share my screen with you?
Yeah, sure.
Okay. Okay. Rakesh, is this correct?
Yes.
It's saying examine the IP routing table on R1. You should see the IP address L-local and IP subnet C-connected. Where
That
does it
not
show that?
see if you want to run any show command here in this prompt right now,
Mm-hmm.
so you have to use do parameter, do and then command. Let me show you that thing. Type here show IP interface brief.
What was it?
Show IP interface brief.
Interface
Brief.
brief.
Yeah. This command will not work. Why? Because this command is for privilege mode. All the show command will run into the privilege mode in the hash. Okay. But if you want to run this command in this mode, before this command, just put do show IP interface brief.
Do.
Yeah. Do show IP interface brief.
Oh, okay.
Clear this thing?
Yeah.
Okay. So now if you want to check the routing table, do show IP route. Clear?
Yes. Okay. Got it. All right. I'll keep going. All right. Completed.
Okay. So understand like how you had to assign IP address to the interface.
Yes.
Okay, cool. Okay. Stop your sharing. Next thing is discovery protocol. You can say device discovery protocol. So in the device discovery protocol, we have two protocols. One is the CDP and one is LLDP.
Okay. Are you sharing something, Rakesh? I don't see anything.
Okay. Now,
There it is. Yep.
so CDP is Cisco Discovery Protocol. This protocol is Cisco proprietary. Cisco proprietary means this protocol will work only on the Cisco devices.
Okay.
And it is by default enabled. It is used to discover directly connected device. LLDP. It is link layer discovery protocol. LLDP is open standard. Open standard means it will work on any device. It can be a Cisco, it can be a Juniper, it can be HP, any device. There is a standard 802.1ab. This is the LLDP standard. And this is by default disable. Okay. Again, LLDP used to discover directly connected device. Right. So the difference between CDP and LLDP is, first difference, one is Cisco proprietary, another one is the open standard. So mostly in the company, in the production environment, they will use the LLDP only. Another one, CDP, you can say it's slower and LLDP is little bit faster. I will show you how.
Okay.
So as I told you, this CDP is by default enable. So if you run here, show CDP. So if I run this show CDP, firstly, it will give you the timer information. See here. So CDP hello is 60 seconds. CDP hold down timer is 180 seconds. So that means CDP is by default enable and it is sending hello packet, CDP hello packet in every 60 seconds. Okay.
Mhm.
CDP hold down timer is 180 seconds means, let's say router 1 is sending CDP packet to the R2 and R2 is not sending me, right? So how much time I will wait? I will wait maximum 180 seconds.
Okay.
Clear? Next
Yes.
command is show CDP neighbor. So if you see here, it is showing this R1 device is connecting to R2.
Okay.
Local interface, that means my interface is fast Ethernet 0x0, and on other side I also connected with the fast Ethernet 0x0, if you remember. So port
Okay.
ID is the remote port, local interface is my port, right?
Yes.
Capability RSI. RSI means this device can behave as a router, it can behave as a switch, and it can behave as a multicast device.
Hmm.
R means router, S means switch, I means IGMP. IGMP is the protocol which is used in the multicasting.
Hmm.
Clear this thing?
Yes.
And right now this device is platform this. This is the platform, like model.
Okay.
Show LLDP. So this command is not working here. Okay, this LLDP command is not in this version. Hold on. So what I can do? So this time I connected R3 and R4 with the two link. One is the fast Ethernet link, one is the serial link, right?
Mhm.
Okay. So in R3 and R4, I'm not configuring anything right now. So we'll see by default CDP and LLDP, how they are behaving.
Okay.
No. So show CDP neighbor. So right now you are not getting any neighbor. Why? Because the interfaces are shut down. So if interface are shut down, then how they will process the CDP packet, right? So
Right.
just enable the interfaces. Let's say interface on here we have, sorry, not this. Two by 0 and 0 by 0. First Ethernet 0 by 0. So I'm just simply putting no shutdown and interface serial 2 by 0, no shut. Here config T interface first Ethernet 0 by 1, 2 by 2, no shut, interface serial 2 by 2, no shut. Show CDP neighbor. So you can see it identify I connected with a R3. Okay. And
Okay.
again, if I run this command, show CDP neighbor, it should show another link also. Show IP interface brief. Two by two is up. Show interface. Show IP interface brief. Sorry. Show IP interface brief. It should show the serial link also. Okay. Show LLDP. Actually, this version is not supporting that command LLDP. Otherwise, you have to type here this command LLDP run. Okay, the LLDP will be enabled on this device, and after that, you can run the same kind of thing like okay, LLDP show LLDP neighbor, show LLDP detail, all those things.
Okay.
Okay, so regarding this, there is a activity number, discovery number 7. Perform that activity. Share your screen.
Okay.
Discovery number 7.
All right.
All right, I've completed the lab.
Okay. So hold on. You go to the router R2.
Yes.
Go to the config T.
What was that?
On R2, go to the config T. Configure terminal. Yeah. Config space T.
T.
Enter. Type here LLDP space run.
Run.
Enter this command. Okay, this command is running here. So run this command on all the devices.
Okay.
So this is the command to enable the LLDP. By default, LLDP is disabled. So if you want to enable it, you have to run this command LLDP run.
Okay. So for here, I'll just config T.
Yes.
And then LLDP run.
Put this command on switches also.
Okay. Okay.
Now run show LLDP.
On all of
Enter.
them?
Use do show LLDP if you want to run this command into the config mode. Do show LLDP.
Oh, do show LLDP.
Okay. So, and on switch number 1, type show show CDP. Do show CDP.
Do show.
CDP.
What was it? CDT?
CDP. Cisco Discovery Protocol. Yeah, enter. And compare the timers.
Okay. All right. For switch number 2, it says the average has been sent every 30 seconds.
Okay.
For switch
So,
number 1, it's packets are sent every 60 seconds.
so LLDP is little bit faster than your CDP.
Right.
Okay. Now run this command.
Okay.
Show LLDP neighbor detail.
On switch number 1?
Anywhere.
Oh, okay. What was it? You said show LLDP.
But directly show command will not work. Nah? You have to run with the do. You are in configuration mode.
So do show LLDP.
Neighbor detail.
Detail.
Okay. So it is showing you. Just maximize this window. Where you run this command. Hold on. Go a little bit up. LLDP show CDP. Okay, here. So switch number 1 is connected with the switch number 2.
Mm-hmm.
Okay, switch number 2. This is the information about switch number 2, which is the version there, what image is running there, what is the capability B and R, what will be the IP, all those information. So this neighbor detail command is similar to your show CDP neighbor. Clear this thing?
All right.
Yes, any confusion? Any question you want to ask here?
No, I think I'm all good here.
So let take a 10-minute break. Okay.
Okay.
And we'll start once again.
All right. Sounds good.
Yes, Christopher, is there any issue in any lab, any topic till now?
No, doesn't
All
seem
good?
like it. Yeah, we're all good.
Okay, cool. So next topic will be the routing, and that will be the last topic for the day. After that, you have to perform your labs.
Okay.
Okay. Now, routing. Routing is a process to communicate between two or more.
Rakesh, I don't see your screen. Are you sharing something with me?
Hold on, I forgot. Sorry. Now,
Yeah, there it is.
so routing is a process to communicate between two or more different IP subnets. Routing is basically three types. One is static, then default, and dynamic routing. Static and default routing are the manual routing. You have to manually define the destination routes. Whereas dynamic routing is done with the help of dynamic routing protocol. Okay. So firstly, I'm going to discuss the static and default. Dynamic routing we'll discuss later.
Okay.
Static routing. In static route, you have to give a complete information about destination network. That means you had to give destination network ID. You have to give subnet mask and gateway. A complete path. Clear?
Mhm.
Doesn't consume any bandwidth. Okay. So the static routing is like doesn't consume any bandwidth. Let's say in routing protocol, for example, like EIGRP and OSPF, they are sending hello packet to form the neighborship, right? So those hello packet will consume some amount of bandwidth. But here there will be no hello packet, so it is not consuming any bandwidth.
Okay.
Routing table will be short because there will be manual entry, right? So the routing table size will be less, and if my routing table size is less, then it will consume lesser memory resource and less CPU utilization. Provide security. If you are not putting a route for the particular destination, that particular destination will not able to communicate with you. Can be used as a backup link of dynamic routing. Clear this thing?
Mhm.
Let's say between R1 and R2, there is a subnet 12.
Okay.
Between R2 to R3, there is a subnet 23. Let's assume on R1, there is a subnet which is 10. Let's say 10 is for my internal user. On R2, I have, let's say, 20. And on R3, I have, let's say, 30. So firstly, I'm going to assign IP address to all the interfaces, and after that we'll verify there will be no communication between R1 to R3. And after that, we'll implement the static route and we'll see now every network is communicating with each other.
Okay.
Okay. See, normal in production environment on R2, there will be a switch connected, and the switch there are lots of PC. But here we don't have that much of PC. So what I can do, I can create a virtual interface, loopback 0, and I can assign IP address, let's say 10.0.0.1 255.0.0.0. So it will behave as a like a PC. So if I run here, do show IP interface brief, so you can see IP address is assigned and working fine.
Okay.
So same way, I'm assigning IP address to R2. Interface first Ethernet 0x0. IP address 12.0.0.2. No shit. So I'm putting all these command in this document. I will share this document. Okay.
Okay.
So you have to just take care, like that particular prompt is not coming every time. So you have to take care of this thing. But all the commands will be there, right?
Mm-hmm.
Okay, so if you see, this is the diagram, and this just I configure the IP addressing.
Mhm.
So if you run do show IP interface brief, so we'll get all your interfaces are up and IP address is working fine.
Mhm.
Let's say you are on R1. If you try to communicate ping 12.0.0.2, you are able to communicate because that is the directly connected.
Mhm.
But if you communicate 23.1, you will not able to communicate because you are sending the request from the 12 network and you are going to communicate into the 23. So that is a different IP subnet. Before routing, it will not communicate. Clear this thing?
Mhm.
So now we have to perform the routing. So for the static route, as I told you, in the static route, you have to give the complete information about the destination network. So now, so we have network like this 10, 12, 23, and here we have 30 and 20. So a static route. So how you will define a static route? So in the configuration mode, you have to write this command IP space route. This is the command. Then destination network. Then you have to give subnet mask and you have to give gateway. Clear this thing?
Mhm.
This is the syntax. So let's say you are on R1. If you are on R1, C and D. C means directly connected, D means my destination. So if you see, network 10 and 12 is directly connected on R1, right?
Mhm.
Who are not directly connected with me? 20,
Mhm.
23, and 30.
Right.
So that means for the R1, these are the three destination. For R3, there are three destination. Same way, if you are on R2, so 12, 20, 23, these are directly connected, right?
Mhm.
Network 10 and 30, these are my destination on R2.
Mhm.
On R3, 23 and 30, 10, 20, 12. Clear this point or not?
Mhm.
So remember one thing, in the static route, for every destination, you have to put a separate route. So if you have on R1, if you have three destinations, so for every destination, you have to put a different route. Clear this point?
Yep.
Now, here is the default gateway. So always remember default gateway is always first next hop IP address. First next hop IP address. So for example, if you are on R1 and if you want to communicate into network 30, so what will be the IP address of the default gateway? Let's assume here is the .1, 12.1, 12.2, 23.1, 23.2. So what will be the default gateway for R1 if you want to communicate into network 30? Default gateway is always first next hop IP address. Means if you are here, so what will be the next IP address? So next IP address is this 12.2. If you want to communicate anywhere, 12.2 will be your default gateway. Clear this point?
Yes.
So we are going to implement the same thing. So if you see, the network is same. So on R1, we have 3 network, which is 20, 23, and 30. So what you will write, IP space route, this is the command. Then we have a network 20, subnet mask, and gateway. Any issue in this command?
No.
Now, clear this thing?
Yes.
If you are on R2 there are 2 destination. One is 10 and one is 30. And last one, if you are on R3, so IP space route. So here I have 20, now see this diagram and see this configuration. If you have any doubt, then ask me.
Okay.
If we can modify like this way also. Now see this configuration. Ask if you have any doubt.
Mm-hmm.
Any issue in the configuration?
No.
Okay. So let's verify this thing. If I try to ping, let's say 23.0.0.2, you can see I'm able to communicate.
Mm-hmm.
Why I'm able to communicate, you can run this command show IP route. It will show you the routing table. So in show IP route, you can see there is a route regarding the 23. So this route is telling if you want to reach 23, forward this packet to the 12.0.2. Okay, which is the R2 router. So if you go to the R2, if you run here, show IP route. So here R2 is telling this 23 is directly connected with me. So you can proceed the traffic.
Mm-hmm.
Same way, if I communicate here with the network 30, ping 30.0.0.1. So it is able to communicate. How? Show IP route. So if you see, there is a route for the network 30. So that particular route is telling if you want to reach into network 30, then forward this traffic to 12.2, which is R2. Now see here. If you, this R2 routing table is telling if you want to reach network 30, forward this traffic to 23.2, which is R3. So now if you put here show IP route, so R3 is telling this is directly connected with me and you can communicate now.
All right.
Clear this thing, how you have to read the routing table.
Mm-hmm.
Remember one thing, routing is hop by hop. Means you have to configure routing on all the middle routers. Clear?
Yes.
So this is your static routing. Now, next is default routing. Same scenario. Okay, default routing. So now what is default routing? First thing, default routing used with ISP. Normally we are using default routing with the ISP. In default route, no need to give complete information about destination. No need to give complete information about destination. You have to give only default gateway information. Okay, so how you will configure this thing? Same way, into the configuration mode, you have to write IP space route, then 0.0.0.0, 0.0.0.0, and actual default gateway. This value should be original. And this is your destination network. This is a subnet mask. So destination network and subnet mask can be any. Any means 0.0.0. Clear this thing? There is a point which you have to remember always. In default route, middle router always configure with static route. Default route always configure on edge devices. Edge devices, for example, like R1 and R3. Clear? So here you can configure static, on R1 and R3 you have to configure default route, whereas on the R2 router you have to configure only static route because that is a middle router. Clear this thing?
Mhm.
So for example, if I write the configuration, in static route you have to run all these commands, but if you configure the default route, this will be the configuration. So according to this configuration, if you want, let's say on R1, if you want to reach anywhere, then forward this traffic to 12.2 and you are able to communicate.
Mhm.
Because your all the destination is only in one direction. R3 is telling if you want to communicate anywhere, forward this traffic to the R2 and you are able to communicate.
Mhm.
But let's assume there are some computers which are connected with R2. If you put on R2 on the default route, so there will be two default route and both the routes are telling if you want to communicate anywhere, then forward this traffic to R1 and R2. So at that time the router will confuse where I have to forward this packet. So just to reduce that configuration or give a clear-cut picture of the network to the router R2, we are using this static routing on the middle devices. Clear this thing?
Mhm.
So let's say I'm removing all the commands on R1 and R3. Same way on R3. Right? So I remove all the configuration from R1 and R3. So if I try to communicate ping 23.0.0.2, I'm not able to communicate because right now I don't have any route.
Mhm.
Okay. Now, if I configure routing on R1, I configure on R1, right?
Mhm.
Again, if I try to communicate, again I'm not able to communicate. Why? Because my traffic is reaching to the R2, but R2 is not, R3, but my R3 router is not having any route to forward that packet to again R1. Means there is no reverse path. So IP route okay, I define this path also. So now you can see, are you able to communicate or not? Clear this thing? So this is your static and default routing lab.
Okay.
And in your network, this is discovery number 10.
All right, let me share my screen.
Which activity you are doing? Activity number?
You said discovery 10, right? This is the right one.
Okay, go down, 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 down. No, 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 no. You are not doing this activity number 10.
All right, let me close that.
You are discovery number 11. That's why.
Yeah, okay.
Because that is the ACL. Tomorrow we'll discuss that thing, ACL.
All right, let me get out of this time.
I can take it easy, bro. Yep. All right, Rakesh. Looks like I'm all done with the discovery.
It's done.
Yep.
Okay. So these are all the contents for the day. Okay.
Okay.
So do one thing. Just share your email ID so that I can share all these like presentations with you.
Yeah, sure.
Okay.
I'll go ahead and I'll send it in the chat. Is that okay?
Sure.
There it is.